The music is really loud, sorry about that. Let me reduce it a little, the volume. Should be good like that. So it's kind of quiet music, but here it is. If you wanna check it out, it's from Nagumori's music room. So here you go. And actually, let me see. Full BPM. Oh wait, I actually haven't switched the screen. My bad. Um, okay, yeah, seems good. Okay, time to start. So yeah, this is the music from Nagumori's music room, and now let's just start the Advent of God, day 10 actually. So let's see what we have. So yeah, it will be some quiet night. Day 10, and yeah, this is the end actually. Day 12 is out, so we just have to finish that. Hopefully we can finish everything tonight, but I don't think that's going to be possible. And then we are going to resume game dev on, you know, my game that I want to make a demo for in April. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline. Oh no. Oh no. And none of the elves can figure out the initialization procedure. Wait, why is it so hard to say? Procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure. Wait. Okay. Are you ready?
Procedure.
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 Procedure. Procedure. What?
Procedure.
Procedure. Procedure. Procedure. Okay. So yeah, this is the initialization procedure. Okay. And it was eaten by a Shiba Inu. Oh, a dog. All that remains of the manual are some indicator lights, diagrams, button wiring schematics. Schematic? Schematic? A schema. Well, okay. And voltage requirements for each machine. For example, out of oh shit. Oh right. The manual describes one machine per line. Each line contains a single indicator light diagram in square brackets. Here we go. One or more button wiring schematics in parentheses, and voltage requirements in curly braces. Oh, I didn't see that. Curly braces. Okay. Okay. To start a machine, its indicator lights must match those shown in the diagram. Wait. Indicator lights. Okay. Where dot means off and sharp means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. What? I don't understand any of that. Any of that. So an indicator lights diagram like na means that the machine has 4 indicator lights, which are initially off, and that the goal is to simultaneously configure the first light to be off. The second light to be on, the third to be on, and the fourth to be off. Yeah, okay. You can toggle the state of indicator lights by pushing any of the listed buttons. Okay. Each button lists which indicator lights it toggles, where 0 means the first light, 1 means the second light, and so on. When you push a button, each listed indicator lights either turns on if it was off, or turns off if it was on. You have to push each button an integer number of times. There's no such thing as 0.5 presses, nor can you push a button a negative number of times. It looks like an equation, because basically you have the results that you want. You have, what do you have? And yeah, I would say this is basically an equation, right? It's just not written in math, but it's written in logic. So there are two possibilities. Either until now, for now, you can either brute force that by trying every possibilities and maybe going on forever because, actually, I guess that there's a limit. Yeah, there's a limit because there's a fixed amount of buttons and they only have 2 states. It's not like integrals, right? So there's actually a limit and we can just try everything. That's the brute force version. And the other version is to try to solve the equation with some equation solver system, probably. But I guess equation solvers, like with functions, usually try to, take like the derivative and stuff, right, to go to a specific value. But in this case, it's a bit more tricky, right? Because it's like with booleans, and maybe it's not possible to do that with derivatives, I think. And yeah, even with derivatives, you can get stuck. So I'd have to think more about it. But that's my thought for now. You can toggle the stage by pushing any of them. Each button lists. Okay. So button wiring schematic like 0, 3, 4 means that each time you push that button, the first, fourth, and fifth indicator, okay, it's starting at 0, got it? Would all toggle between on and off. If the indicator lights were that, pushing the button would change them to be that instead. Yeah, okay. Because none of the machines are running, the voltage requirements are irrelevant and can be safely ignored. Okay, it's just ignored. Okay, it's just for the passing. You can push the button as many times as you want. However, to save on time, you will need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. Okay. So basically it's like it's not death first, it's breath first. There are a few ways to correctly configure the first machine, which is this. This machine is the first one. You could press the first 3 buttons, one each, total of 3 button presses, or I could do one once, this one once, this one twice, so 4, or I could press all buttons except this one. However, the fewest button presses required is 2. One way to do this is by pressing the last 2 buttons, this and this. Second machine can be configured with as few as 3 button presses. Okay, one way to achieve Yeah, I mean, I get it, right? The fewest presses required to correctly configure it is 2. Okay. Analyze each machine's indicator lights diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights on all the machines? I guess this one is going to be used in the part 2. Got it. Button wiring schematics. What is the fewest? On all the machines. What do you mean? Oh. Is 2. Oh, so yeah, because you just fuse the minimum. You just add the minimum, so okay, I get it. Okay. So day 10, here we go. Let's get ready. Boo. Let's remove the inputs. So we are sure that we have the most recent ones. I had so many things for day 9. It was so big. And so many wrong things. I do like bisect. I actually want to keep it, but I'm actually not going to use it. And I don't think I'm going to use plot either. So let's just do this. Day 10. Inputs. Now we have. So the first one, the example is this. So test input. And my input is this one. Do we have a lot? That's fine, I think. Yeah, sorry. I'm a bit tired from this week, but I'm good. So, I don't want to plot. Yeah, there's no duration. What was I supposed to do? Okay, let's actually do something. Let's get this, and let's copy it maybe there, so that we can actually see what it is about. So we have well, just parse inputs, maybe. I don't know why I'm putting this here, but here it is. Yeah, let me just put that in comments so that we have an example, basically. So we have the content. We have the split lines. We have 4 line in lines. And now we're going to split. I guess there's no invalid input, which is good. So every time we split, we have... Well, actually, we have spaces here, right? Oh, for each thing. Okay. I mean, I guess we can split with spaces. Yeah, I guess that's fine. So we have this, we have messages, let's call that. So message 0 is Yeah, let's actually make a class machine. So we have lights. Was that it? Yeah, lights. Lights. Then we have, I guess it's an array of booleans. Then we have, because booleans are like 2 bits, so maybe that can be fused together in Python to optimize that. Then we have buttons. Switches, which is a list of integers. The integers being the indices, right? And at the end we have something that's not used for now. Okay, that's fine. Yeah, that's fine. So we have machines equal a list. Then we append a new machine at the end. And we are just going to set lights to the first thing. And then we have to append each switch basically. So for the first one, I mean, I guess the first one is just about, wait, is it actually, wait. Oh, that's the target, right? Yeah, that's the target. Let's call that target lights. And then this is light. This is light. Yeah, for I in range, okay. From this to len of messages 0 -1, because we don't want the last character in the first one because they are these things, right? Square brackets. Oh, that's how you call that? Square brackets? Oh yeah, it is. I didn't know that. Nice to know. Since I always use that in programming. Okay. So message is 0i we add. Oh, we add. We're just going to add whether this is equal to this. If this is, then this is on. And if it's not, then this is off, right? So that matches things like that. Then we have something kind of similar, starting at 1, finishing at this time, this -1. It's a bit, wait, actually, this -1, it's a bit different, because this time we have to iterate over all of those. I mean, I guess that's actually some regex syntax that I can use. I actually don't use them a lot, so I actually do want to check it out a little. But I guess I would still have to convert into integers, right? Find all. Okay. So for example, let's say we have this. Sorry for the Japanese. Um, Re.search. This. Wait, what? Multiple. I know recursivity is not possible with regex, right? Let's find all. So yen is just backslash. And any digit, yeah, but it's not numbers. So because yeah, it's passing characters. So I don't think that's possible. Yeah. I mean, I guess I would have at the end a list of characters, kind of. Oh, wait. Okay. Oh, you need to anchor the regex at the start and end of the stream of the string. Start, end. I prefer. Yeah, regex becomes like. I know that regex is regular expressions are supposed to be the clean way to do things, but every time I look at it, I'm just like, how can you say this is clean? It just looks like magic values everywhere. So basically, you have the end, you have the start, you have what? At the start, if there is minus or plus, then you get something, characters from 1 to 9, all characters possible, or 0. Yeah, but this is just 1. Yeah, okay, let's do it the normal way. So we have these. Yeah, we have those. Can I just... Oh yeah, I can do something about this. Because this is basically just messages from 1 to -1. But like, you know, we remove the last element. And then I can just convert that to an int. Yeah, I don't have to use regex. Yeah, okay, this is better. This is better. Then we append the machine, and then we return the machines, right? So this way we're going to have some clean interface to do our things, because I don't want to stay on strings. And yeah, just thinking, you know, it can increase some, to be honest, maybe not performance, but yeah, you know, maybe just memory, but I mean, runtime is not going to do like much really, but that's fine. We have the machines. It's more that, you know, to make it easier for ourselves. Here we go. So we have the machines. So the goal is to find the minimum amount to get this. Got it. So for machine in machines, we have the total equals 0. We add total plus equal min iterations. Then we return the total. And this is good. And now for the machine, what we have to do is just find the minimum, right? Just find the minimum. Get the machine minimum iterations. I mean, that's fine. I could make a function here, actually. I mean, yeah, find mean iterations, maybe. Then we have machine dot find, yeah. Here we go. And this is actually, yeah, this is actually just this, okay? This is quite simple, really. So now I have this. What do I do? Well, basically, that's kind of simple. I have to, basically we have different possibilities. One is using recursion. Which in the case of recursion is like def first always, right? So it's going to be kind of bad anyways. And the second one is the better one, the iterative version with the breadth first BFS, which is going to be with a stack, with a, wait. So a stack, I put an element. It's a queue actually, it's a queue, I want a queue. I don't know if there's a queue in Python, but I mean, we can always have some kind of circular array. If there isn't, okay, there is. Q.py. I think from Q import Q. Which one? I mean, this one is better, right? I feel like. What is this? Is it like standard? It's Anaconda. Oh no. Makes sense. At least Q. Yeah, collections that, wait. G philo FIFO. Yeah, I mean, I guess the one from Asyncio is better. Oh yeah, never mind. It's not from Anaconda. I'm kind of stupid. Anaconda is just my Python. So what is this? What is it actually? Where is it actually from? Lib. What is lib? I don't know. Can you check the Python documentation? Yeah, this is lib slash. Okay, this is standard, probably. So we have the queue. A. So now we want to add to the queue for I in. Let me think. I guess switch in switches. So we need a self. And we need to initialize the queue. To create the queue. And then we can just append, push, put an item into the queue. Okay, that's fine. We put every switch. This is simple. And now while yeah, okay, this can be I was gonna say a bit tricky. No, it's not, but that's fine. I guess we should have some kind of memorization still. Like some kind of set that can tell us when to stop. Or maybe, actually we want a table. Yeah, actually a table is better, because we just have an array of switches, right? So yeah, it's kind of DSP in a way. It's not DSP, it's just some cache. We can just use a table for the memorization. And then we have every different possibilities. So that means the table is going to be a cache table. It's going to be a list of booleans. So let's hope it is optimized memory-wise. Yeah. I was just thinking it's like power 2, right? That can grow very fast. But actually it's not that big, right? Like none of them are that big if you look at it. Like the biggest is maybe this one. It's like 12 characters. So we have 12 power 2, which is just like 100 and some. And we can compute the cache of everything. The hash, you could say. So this is just an array of size. Let's have, I guess max cache, max. Oh yeah, actually we can combine that. So we have the amount of switches, right? So yeah, this is just that times len self.this times this again, like nb. It's not. That's not actually true. Well, actually, yeah, it is. NV switches. Here we go. So this way we don't call the len function 2 times in a row, which is good. So we have the cache table. So amount of possible unique combinations, right? Let me think, can we optimize that? Because I was thinking this is okay. So basically there's a very good property, is that it's how do you call that, commutative, right? And associative, I suppose. So that's great. So basically you have, so you know how for matrices, for example, you have m1 times m2 that is different from m2 times m1, right? But for integers it works, it's equal. And for floats it works. For quaternions it doesn't work. And you know, you have different properties for different fields. Yeah, fields, I suppose. Well, for different how do you call that? Well, things, I suppose. Yeah, I forgot. In this case, if we have the first switch and then the second switch, then this is the same as doing the first, then the second, right? So that's an optimization. That's an optimization we can catch with the cache table, actually. So I wonder if we have to do that, kind of. Just wanna check something. Is there any of those that is like completely off? I feel like there's going to be one of those. There isn't. Okay. Okay, one edge case removed, I suppose. But I mean, for I in range, let's just have this. Well, I guess never mind. I can just do that at the beginning. Right. Wait, I just... He has the cache. Oh. That means I can store even less. Ah, interesting. Interesting. Since I can assign every combination... Yeah, actually, this is just a number, right? I can just assign a unique number to every possibilities. Oh, that's actually nice. That's actually a number. And this is actually not a on-off, this is actually a XOR, right? Yeah, this is actually a XOR. Why do I have a list of ints? If... Wait, even this was wrong, I suppose. What am I doing? Yeah, this is not a unique number, right? But for some reason I just added it as if it was. One, two, three. So yeah, it's starting at 0. So yeah, I guess this is actually a number, but we have to split it. So okay, let's do something better. So we have numbers dot split. Yeah, I guess well, yeah, it's a range. I should be able to split. Why not? So we have messages. Oh yeah, this is bad. I didn't take I. So I have one message. Do I have separation? I have one message. I can take, well, remove the first and the last one. Then I split with this. Okay, numbers str. And then for all of those numbers, we're going to do something really nice. Number str in this. Then we are not going to append directly. We are going to have a hash. Hash. I guess it's like bit-wise. Bit what? Bit representation? Bit... What is it about, actually? Bit light ID? light ID. Huh. Huh. Light bits? I don't know. But it's actually not about light, right? Button wiring schematics. So button, well, switch bits. Yeah, switch bits, maybe. Okay. So this is 0 at first. And then for all of those, what we do is for every number, we're going to add this, at this. So yeah, we're just going to shift every time. Shift every time? Um, hmm. So this is an integer. Let me just think. So basically no. The switch is going to be about the number, this one, for example, and we switch like a certain amount of times. And I guess it's just plus equal 1 pushed. So let's say, oh, not that's number string. So let's say this is 0. Then 1 moved 0 times to the left is just 1, right? So it's like on the right. Well, if we go from right to left, right? So it's like big endian and small endian. I guess it's small endian, right? And then yeah, if we have 2, then it's going to, well, if we have 1, it's going to move 1 time, so we are going to have like 2 or 3. If it's like here, if it's 2, then it's going to move 2 times, so we are going to have 0, well, 1, 2, 4. So 4 or 5 or 6 or 7. And then we are going to continue moving. And we have the bits basically that we happened at the end. And we have the switches that are integers. So this is right. And now that we have that, then the switch is just an operation with a, well, it's just a XOR, right? Exclusive OR. So we queue. Let me think. Stable. Yeah, I wanted to verify if self.switches. Is it switches? And yeah, I guess it's not a list of booleans, right? It's a list of, well, it's just an integer actually. It's actually just an integer because it's stored in bits. I mean, I guess in Python we might have Python bit fields, maybe. Standard structure and union features of C types. Hey, C types. Yeah, C types is good, but isn't it like for like exposing your Python library to like other languages? Bit array. It's a C extension. Yeah, I mean, I don't need that. I don't need that. So okay, for every switch. So yeah, actually it's just if target self that target lights. If it is 0, that means if everything is off, every target light is off, then that means the amount of iterations I need is 0. I just need to fix this now. So this is I, and this is a Boolean. So if this is true, that means it's going to be different from 0, like 1. It's going to be 1, so that means I can then bit shift that depending on I. Something like this. And that means I can just target lights happen. I can just press equal. And this should be fine, right? Just adding some parentheses, just, in case. Because I feel like this was going to be run first, but okay. And we prevent a if, we prevent a condition. Hey, this one was hard. Buttercup, hello. I mean, the first part doesn't seem hard. It looks like there are like a few elements that are kind of funny, right? You can actually optimize this quite a little. So that's great. You have my cache table. Maybe I'm going to have to remove all of this for part 2, but well. Switch 1, switch 2. Yeah, this is commutative, associative, all of this. So that means I only... That means it's only a table of... Wait. Wait. Let's say I have 8. Let's say we have 3 switches, right? Yeah, I guess this is... yeah, okay. This is... basically 9, right? 9 possibilities, so yeah, that's power 2. And I don't have any... Yeah, I can't really optimize that. Well, anyways. So yeah, how did you do it? Did you finish it? Cache table. So we have the switch, which is an integer. Is it? Let's say it is. Can I do that? I don't know. I don't know if I can do that. You know what? Let's first try to run it, because we might have some problems with the inputs and stuff. So, run. Yeah, I finished them all now. Whoa, well done. Was it like the hardest, or do you have even more difficult afterwards? String has no number, find minimum iterations. Oh no. Wait, what? Machine. String? Wait. Machine. Wait. What? How? Wait, what? Oh wait, okay. I mean, okay. That's fine. Here we go. Like, if you had to rank the hardest problem, which one would you say it is? Unsupported type, a string and int. Yes. Makes sense, right? So for every messages, not at all, not messages. But yeah, you got me. Should be something like this. Oh, they 10 for sure. Oh, so this one is the most complicated. Oh, okay, that's fine. I hope. Well, let's see with part 2 because, yeah, for now I'm kind of glad. Int object is not iterable. What do you mean? Int what? Is it because of... Wait, I can't... Wait, can you bit shift in Python? What's Advent of Code? Hey, Advent of Code is some kind of programming challenge. It's a programming challenge for December, for kind of before Christmas, that releases a new problem every day and every year also. And you have like 2 parts to every problem. And this problem is about basically switches and lights and yeah. So basically you have multiple, well, this is a, well, you start with lights off, okay? Like every light is off at the beginning, okay? And this is the target that you want. So you have 2 lights on in the middle, and you have lights off on the side, okay? For this lane. And then for, well, and then you have a list of switches here that basically switch a light. So this one is free, so it switches this one. Oh, that's cool. Yeah, yeah. It's nice. And yeah, you know, towards the end, the last problem actually released today, I believe. But yeah, I'm a bit late because I took some breaks during the evenings. So here we go. And yeah, int is not okay. Python bit shift. On integrals. Oh wait, bitwise operations. Bitwise operators. So yeah, they do work. Oh, but I guess that's because it's a Boolean, right? Wait, int object is not iterable. What do you mean? Oh no, it's this. Okay, my bad. So we have messages, and then we have this, which is a character, maybe? Yeah, I think this is a character. Never mind. Okay, then we have this. Then we check. This is true. Then this is not going to work. Oh, this is actually working. This is actually working as intended, but target lights is a list. Okay, I get it now. Yeah, okay. Yeah, I forgot to remove the initialization. Okay, so it should be good. Machine has no attributes target lights. Does it? Really? I would say it does. Switches. What? 0. Oh, because we do a plus equal. We start with a plus equal. That's why. Dude, finished AOC. Well, well play, Icarus. No, it's Carcass. Not Carcass. Well done. Still have three problems myself. 6 parts in total. So let's see, and yeah, let's maybe see together if we have, you know, different optimization that we didn't see. Like if I'm doing some optimization that you didn't, and if you had some optimization that I didn't, would be like a nice exchange. So I have an amount of switches. Yeah, okay, that's fine. That's normal. Integrals all. Great. And now, basically I'm getting here. I have my Q. Ooh. And for every switch, or switch in switches, whoa, in self.switches, I'm going to what? Yeah, to add it to the queue, right? Put. What is put no wait? Puts an item into the queue without blocking. Only enqueue the item if a free slot is immediately available. Override raise the full exception. Wait. Oh, because it's trying to resize, is it? If a free slot is immediately available. Oh, that's kind of sick, actually. Can I reserve? All tasks done. Oh, cool. Method is likely to be removed at some point. Oh no! Use queue_size as a direct substitute, but be aware that either approach risks a raise condition where queue can shrink before the results of full or queue size can be used. Shrink? Because basically this queue supports multi-threading, and I don't want multi-threading because it's taking some performance. Not reliable. Why? Do I have anything reliable? Max size, what is it? It's just an integer. How can I reserve? Let's check Python Q max size. Python's maximum size of a standard determined by the max size. The Q max size is an integer group. Oh, maybe I can set it myself actually. Max size is 0 or less. Q is infinite. Okay. Block. Oh, that's something for me actually that I have to say. Yeah, okay, it's actually not memory. It's not a memory thing. Reserve. Yeah, I don't have that. Things are going to be so bad. That's fine. So, okay, let's stop this. So for every switch we are putting, well, the switch in the queue. Oh, not the queue in the queue, but the switch in the queue. Yeah, that's better. And then for every... Oh yeah, I was actually doing that, but that's fine. For every elements of the queue, I'm going to pop. I can't pop. Can I maybe get? Timeout. So block is true. Timeout is none. I mean, get is a pop, right? Remove and return an item from the queue. So yeah, it's a pop. So let's do while queue is not actually return true if the queue is empty. Yeah. Not reliable? What do you mean not reliable? This method is likely to be removed at some point. Is queue size. So what happens if I just pop? What is it? Pop. It was a get, right? If no. Wait, so how to loop through a queue, actually? How to loop through a queue? Python, how to loop through a queue. Because if you don't know, yeah, well, true. I mean, yeah. Oh, the iterator. You can use iter with callable. It pass two arguments. One for the callable, the other for the sentinel value. Replace as none. This will block when no elements remain and no sentinel value is put. Yeah, okay. So like a while get loop, and unlike normal for loops containers, it will remove items from the queue. Yeah, that's fine. None is common value. So here's a sample. With more concrete sentinel value. When do you join? For I in. Yeah, I guess I don't need the I. Yeah, I don't need the I. But is it removing? Is it popping? People are doing crazy stuff. They're getting crazy. Yeah, why is it so hard? I thought Python was good. Well, not q.empty could work, because it's not reliable. Look at this, it's not reliable. I mean, it would work in practice. It's probably not reliable because, you know, thread safe and stuff, and we have only one thread, so I mean, it should be reliable. But I want to use the reliable version. So I actually want to check if we have basically a switch in queue, print switch, and this is it. Let's see if it goes on. QObjects is not iterable. I'm gonna make a list. I'm gonna make a list at this rate. Like I'm going to make the queue myself. Uh, list. Wait, what? Wait, is that a view? Oh no, that's so bad. Iterable queue. Oh, that's a wrapper. Yeah. Line. Okay. Yeah, I'm just going to do it the normal way. So wait, just what? We said for I in. Yeah, that's not working though. Oh, Q. Oh, Q.Q. Wait, this is Q.Q. This is Q. This is Q. That's Q. This is Q.Q. But yeah, of course this was Q.Q. And this is the Q. Q.Q is not a Q, it's a DQ. This is crazy. This is crazy. Okay. But yeah, we have Q.Q. we have q.q, so this is fine. The semantics are killing me. So it's printing a lot of values actually. Is it because, yeah, let's just try testing it. Oh, so it's printing everything in the lists because there are multiple of those. And it's not looping forever. Well, yeah, of course it's not looping forever. The question is, can I actually push into this? I mean, yeah, I'm doing a for each, so I guess I can't, right? I mean, I'm doing that, but in the end, I guess I can't really do that, or it's going to make it invalid. So, okay, let's just do a queue that is, well, empty. What is not empty? I saw something. Maybe not. Not empty. What is that? It's a condition. What? Thread waiting to get is notified then. I mean, I guess I could make it multi-thread actually with all of this, right? I mean, yeah, I could definitely make it multi-thread, but yeah. But I guess I still want to. Actually, never mind. Yeah, you can literally make it multi-thread. Yeah, and I actually figured out something great. Q. I actually want an ID. Wait, do I? No, I don't. No, I don't. Okay. Okay, let's do it the normal way. While it's not empty. Right, this is Python. Well, this is not empty literally. Then I'm going to. It's not pop. It's get. Yeah, this is killing me. This is killing me. I thought Python was supposed to be easy. Why is it so hard? So we have the switch. And I guess we have a state. We need a state that we are not storing right now, which is a problem. So I guess this is actually the next state that I want to. So basically, cache table is fine, but Q is next state Q. Okay. And this is important because we are not going to put switches inside. We are going to put the next table. First time Python has confused me so much. Yeah, I mean, Python, I think people say this is pretty, easy. Well, people say that this is a simple language, but since everything is hidden, like even types at first, you're going to encounter like problems. You're not going to understand why. Like, yeah, this is actually kind of confusing, I would say. Like, I understand Python pretty nicely, but a big part of it is because I actually started with C and C++, and I can just represent the internal working of Python in C and C++. So basically, for me, you have in Python a big dictionary, a big map, okay, in which you add function and variable objects that are basically classes that inherit from objects, most of those. And that's why you have references with classes, right? And you can also, yeah, I guess like C#, you can put it into an object class that can become null if you want. And it's like Well, basically you have a pointer that points towards these things, and you have stuff. Anyways, it's the downside of so many libraries, I guess. Um, oh yeah, I guess you do. I guess you do have a few libraries, well, a lot of libraries, but I wouldn't say this is a big problem for me because I don't use a lot of those, right? I mean, basically Matplotlib, NumPy, I mean, some stuff for deep learning I've used, but you know, what else? I mean, yeah. So let's get the next one. We have this is not a switch. This is a state. And we are just going to check if state. Well, I guess we could have done that beforehand, actually, before adding it to the queue. Should we do that? Anyway, let's do it simple. No, let's not. For switch in self that switches. So for every switch, what we are going to do is XOR that. So state XOR switch. And what it's doing is, I'm going to put a comment for people that are watching basically, but I know what this is. This XOR is switching the bits. Switching the bits as if we were switching lights, right? This is basically what it does. Okay. Light 0 is at bit 0, etc. So it's a logic gate, right? Yeah, it is. It's like the same as a logic. Wait, no, wait. What's that? Oh, but it depends what you mean, because it's also an arithmetic thing. Basically, if you have booleans, then you have like a boolean, you have a second boolean, and in this case, b1 XOR b2 is equal to b1 is not b2. This is the same thing. And for integers, it's switching bits. So yeah. So yeah, basically this is doing the same as this with booleans, but with bits on an integer, with every bit on the integer. So yeah, this is some kind of extension. XOR is the best logic gate. Yeah. Yeah, I agree with that. Because you can do some crazy stuff with XOR. Like, in encryption, for example, it's like, fast, and you have some nice optimization with this. Like, the lights thing, right? This is already a pretty nice optimization. And this is basically the state is going to, well, let's just create a variable new state because we need the state for next iterations of this. Then we switch if new state equal self.target lights, target state maybe. Most important thing is, yeah, this is A XOR B equal A. It cancels out, and that is magic when it comes to bitwise work or data validation. Yeah, totally. Like a simple way to encrypt your data is just XOR, but it's not really encrypting. I mean, I guess, yeah. Anyway, and the other one is I'm thinking about a really good lead card problem. that has to do with the XOR, that is 3 elements in one list, like duplicate, like single number basically. This is the one. Well, these are the ones. Like the simple one that I did was this one. And here it is. Every element appears twice except for one. Find that single one. And in normal cases, it would be like, you have to go through the list multiple times, right? Or like maybe have some kind of map actually. Yeah, some kind of dictionary. But well, basically have ON memory cost. But with XOR, well, you can just go through that and you have only one integer to store. And it's like you have O1 memory instead. And it's like crazy. I really love this example because it's like so simple. And it's like so great. So you're going for XOR switching with a bit mask? Yeah, that's it. Because we just saw that that's input actually. We saw that like the maximum of characters we had, actually it's not 12, it's like something like what? 10, right? Like, what is it? Yeah, it's 10, I believe. So we, as long as it's less than, so I guess an integer is like 2 power, not powers. So 8 bits. Oh wait, it's 8? So yeah, an integer is like 8 bits times 4 because 4 bytes. But I guess we could store that in only one character actually. We could use like only one character for that. And like it would optimize the memory even more. This was my solution as well. I brute forced part 1 with XOR and bit mask. Yeah, I mean, I guess that works, right? Yeah, I was gonna do the same. I'm just thinking about maybe if there are like different possibilities. Because I feel like you could get to some primitives or something, but yeah, I guess you can use some dynamic programming in some way. Can you? I mean, that's basically what I wanted to do with the cache table. I'm just not using it. Yeah, I mean, I just have to fill the cache table and find the minimum. The minimum to... Not the minimum. Wait. Wait. Yes, I can do some DP. So let's say I have a big array, a 2D array, that contains the amount of switches to get to that number. Then I can... Well, I guess I have to XOR anyways. Let me think. Yeah, I can't get on a specific value and try to compute it using previous values. I basically need my queue, right? Yeah, I need the queue. I need the queue. Wait. Do I... I mean, yeah, I need the queue. Damn, someone served this in assembly. Whoa. Strong. Yeah, I actually wanna see how it looks like because I haven't looked at a lot of assembly and I guess I'm kind of, interested, like technologically. Anyway, let's continue. So we have the state. If this is equal, then that means, yeah, but we actually need the amount of combinations. I actually didn't store that. That's a problem. So state, okay. Let's have this and this. And this is basically state and NB combinations. NB switches. Have you tried incense for your CPU? Incense? I haven't. I don't even know what this is. A system for displaying data structures. Wait, is that it? Yeah, no, that's not it. There's a E. Yep, one of the fun things about AOC, every year some people whip out the most random, hardest languages or tools to solve them, and then I'm just here with Python, right? Half of the time it works all the time. So Warhammer, okay. Yeah, there's actually a pretty nice solution that is, while state is not target state, then we have state XOR equal switches dot random. Yeah, I'm sure this is going to work, right? Oh no, you need the minimum amount of iterations. Oh no, it's not going to work. Never mind. My bad. We need more random. I've not watched many solutions this year, but last year one guy solved a lot of the days by just using Envy. Yeah, this year I'm not taking it like very hard. I'm just Pythoning. I guess I wanted to finish the Advent of Code like at least one time, right? I actually kind of wanna stop now, but because I want to focus on my game. But I'm like, I'm so far in, and next year's it might be 24 days instead. So let's at least do the 12 days, okay? And this has actually been a great refresher for some Python things and stuff because I guess I wouldn't use Python now otherwise because at work I use can I say it? Well, I mean, it's the basic languages, right? And and yeah, for my game I use like GDScript. So no Python. I guess this is pretty similar, but not not that much. So if this is equal, what do I do? What do I do? So yeah, this is supposed to be the minimum amounts of state, actually. So I should just be able to return, maybe? So we have state, we have NB switches, and I just return the amount of switches because this is a queue. So that means it's always going to go from the lowest to the biggest number of switches, right? And what that really means is that it's always going to be increasing. So I don't have to wait for a smaller value to come in. So this is great. I can return directly. And if not, then I can just push. So I can just put in my queue switch. Switch. Wait, this is not switch. This is. Wait. Wait. Well, I guess this is a switch. So this is state XOR. Oh, yeah, this is just new state. I already computed it. And this is NB switches +1, of course. Okay, this should be fine. Actually, I think we might be... Wait, is it already the end? Maybe this is it. Is this it? I feel like I'm missing something, but I can't really say what it is. Oh yeah, the hash table. Yeah, because we're just going to loop forever. But I mean, even without... I mean, if I don't use the cache table, it should still work, basically. It's just not going to stop, but it's going to work, probably. 4. Is that the correct? 7. Oh no. Okay, maybe let's print. Let's print. Where is it? It's here. NB switches? No. Return. Oh, I guess it's returning 0 at some point. Like, I guess I actually want this to be an exception or something. Asset false. Let's just put that. And if I return, I want... I actually don't have the states. I can't do that. Yeah, this is... I guess this is a problem with optimizations. So, okay, this works, but the problem is that I don't know at all what I did to come to this 4. Oh yeah, I guess I actually wanted print NB switches. So I have 1, 1, 2. Oh, I only copied 3. Wait, was it only 3? Okay, 1, 1, 2. Yeah, this is 1, 1, 2. Wait, this isn't how it's supposed to be. XOR. Yeah, the XOR is... Oh. Oh. I forgot something. This is not an equal. This is not an equal. Is it? Because basically I'm going to have more bits. I'm going to have more bits. Probably. So yeah, and this is 8. This is 8. Wait, this is 8. Wait. Yeah, I'm afraid this is going to give some crazy... Yes, this is 4. This is 12. So we have 4. And we have 8 plus 4, so this is 12. Right? 8. 12. So wait. 1, 2, 3. My bad. 4. Never mind. Yeah, this is 4. 1, 2, 4. Wait, 4? I wanted 8, right? 8, 12. Yeah, so 8. and 12 is 8 plus 4. Oh, yeah, okay. So I have this. New state is 8, target lights is 8. I think you can actually display this in, like if I do, I don't know, maybe a B. No. Visual Studio display integrals as booleans, as bits. Visual Studio Code debug. Oh, it's okay. It's a comma. It's not this. It's a comma, or maybe not. In the name column, add your variable followed by this b. Yeah, that's not working. The name, you said? No. To binary. I guess I could do this. Eggs. Basically, I can have this. It's just a bit more work, but that's fine. And this is integer is not defined. Oh no. What about int? Yeah, it's not going to work. Maybe it's no. X or octal. Oh, how is it? Just place before eyes. What? Visualizer. Oh. Okay, we have some nice things apparently possible, but not here yet. Maybe as an extension. But anyway, we have this. This is actually going to be a problem if I continue like that. So Python int to bit array. I actually have to bit field. Yeah, I want a function. I don't really want that. I mean, this works, but because this is too long. Bin binary string. It's bin. Oh, wait. This is great. Bin sounds great. Bin is fine. Bin is good. Okay, so this doesn't have previous bits. I was worried about that, but in Python, I guess this is fine. This is so great because I was worried that if we had, for example, this and this, then the XOR would do something like this, right? That makes sense, right? Is it? I guess this is it, right? So I'm kind of glad it's not like looking at the bits that are before that. Because if it was, I would have to use a mask every time. That would basically remove the first values. So basically you have something like a mask that's computed depending on the amount of things I have in my target lights. And then I would just do the XOR, and I would combine that with the end mask to mask it. I mean, I guess I can still do that, but I guess it's not really necessary in Python. I guess for the love of the sport, let's say. So what should the mask be? I guess 0. I guess I have to find the amount. I guess I have some way to do that. I guess one simple way is target int. So basically I want to use the OR. And let's say this is 0, okay. No, this is not 0, this is self dot target lights. And we have while this is not 0, then we just have our mask that is 0 at first. Then we are going to OR that to the target. And then we are going to move the targets to the right, like this, with a equal. So basically, we are going to have, let's say the target is something like this, okay? Then that means if you represent it with an integer, it's going to be like something like this, okay? Maybe like this. So now what I'm going to do is I initialize mask at 0. Now I do the end, which is this. And then I move this one to the right, like this. Not the end, my bad, the OR. So I use the OR again. So this one is 0, this one is 1, so it's staying as 1. This one is 1, this one is 0, so it becomes 0. And you continue like that until basically you consume everything here. And that means every bit is going to be occupied. And I guess the maximum amount of loops possible is like 32 if you're using integers with 32 bits. But I guess in our example it was like 8, and it's like only once at the beginning, so that's totally fine performance-wise, because I guess this might... I don't really know for sure if that's like the fastest way to do it, actually. Maybe you can, manipulate bits yourself, but yeah. I guess you can do... Or yeah, I mean this is fine. So we have this. Okay, now this should be good. Let's do this again. I mean, I think there's still a problem, but 1 1 1 3. Yeah, there's definitely a problem. There's definitely a problem. So the mask is maybe not valid. Yeah, because it changed the outputs, right? So this is actually 15. So this looks pretty good, because this is a pretty high number. Or you trust upon a random cosmic ray to flip the bit for you. Yeah, I could do that. I can see that. I can feel that. I can feel the ray coming right now. So 15, 8, 8. Why 8? Let me check the test input, the example. So I guess we have those here. So we have nothing. Wait, so what's the target? What even is the target? Wait, what loop is it? So this is switches is 8, 10, 4. So many numbers. Wait, what? Why so many numbers? Wait. Did I do... Oh no. No, actually that's fine. Okay, we have an ad break. Let me be right back. Boo. Okay, I'm back. Sorry about that. Two missing in... Oh, wait. Hello. So, what were you saying? On my first day of Christmas, my GitHub gave to me a merge conflict. Oh no, two missing imports. Wow, Christmas is really coming early for you. Well, wait, on the first day of Christmas. Yeah, I'm glad we have Christmas 2 times a year. Okay. Let me check. No, not that. Oh no, wrong one. Okay, good. Okay, so yeah, I'm just going to talk maybe a bit less loud. Let's just have some, casual, well, monologue. Some casual monologue. Maybe dialogue, but I'm just going to read the chat. And yeah, just thinking a bit about my neighbors. And, hopefully it creates like some kind of good ASMR environment. But anyway, so we have the new machine, we have the switches. What's wrong with that? So this is, what machine is it? Switches. I have 14 of those. Like, 14? That's like a lot. How is it even possible? Target lights. switches. So for every message, let me check test input. 1, 2, 3, 4, 5, 6, 6. This is the maximum we should have. Tell that to the outer. Let me check the input. Yeah, this is a bit too crazy. That definitely shouldn't be this much. Now I understand why there are so many. Oh, it's because it's in. Wait, 1. Oh, that's the same. Wait, let me actually check if it's really the same machines. We have. Wait, it's actually a different place in memory, but all of those have the same element. Was seen in Japan. Actually, I thought it. Well, I thought it would be like not that thin. Well, no, that's the opposite. I thought that in Japan the walls would be like, very thin, but it's actually quite alright because you had a lot of complaints, I guess, a while ago about walls being thin, but it's actually pretty fine. I suppose maybe my neighbors are just not being loud, and I'm just being the only hassle, that just making a lot of noise like at 1 a.m. But no one seems to complain or anything. I mean we're in Japan, so maybe they're not going to be. But yeah, let's still voice it down a little if possible. So we have, yeah, I guess it just keeps a reference to that same array. So the problem is actually in parse inputs. Before appending here, I should just put a new array. Not going to complain, but will curse you on 5 generations. That's right. There's going to be an anime about me being the main villain, and Yokai is just cursing me. Okay, what do we have? I guess I actually wanted to check the machine. Oh, I guess we are in the machine. 8, so 1, 2, 3, 4, 5, 6. 6. And we start with an 8. 1, 2, 3, 4, 5, 6. And we start with, I guess, so 1 is 2. Wait, which one is it actually? Let me actually verify if this is correct, if the inputs are correct. I mean, I feel like I said that just before, but machines. So we have the machines. We have like this one that has a target of 8, and that has those switches. I feel like this is wrong. Wait. 8 is like. So wait, this is supposed to be the first one. And the first one is that. And 3. So we have 0. Oh. 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 向かってくるのか。 このディオに近づいて向かってくるのか。では、十分近づくがよい。I just remember it somehow. I just remember. I don't even speak Japanese, but I somehow remember it. I'm kidding. Target lights. So yeah, let's say we have 0, we have 1. We have 2, we have... No, yeah, we actually have 2. We have 4. And we have 8. So this is 8. And the targets... What? Wait, what? Target light is 8. This is 8? Because I mean... And this one should be... Oh, it's not... I mean, the press should work. But yeah, there are some pretty funny things. Oh no, this is... Okay, this is 8. So this one is correct. This one is 8 plus 1. Never mind. Yeah, so 1 is 2. So 8 plus 2 is 10. So okay, switches are correct. But the target light is not correct. Because target light is this, right? So the first one should be a dot. So this is not equal. So this is 0, I believe. Nice accent, though. Thanks. I feel like I could have done better, actually, but... Thanks. Japanese people say that I have a bit of a French accent in Japanese, too. I feel like Japanese is a lot closer to French in the pronunciation, though, than English. Because English, you have to, you know, change the intonation and stuff. But in French, it's like flat, basically. And in Japan, in Japanese, I guess you have some accents, but like not a lot compared to Chinese and stuff. And it's like, you know, a bit implicit, so it's fine. Maybe it's not, but yeah. And like, I guess English is just pretty wavy, I would say. Not for French slang. Oh. Target lights. Yeah, what's happening with this? Why is it 2? Wait, why is it 2? Wait, why is it 2? Like, really? Why? Why is it 2? Wait. What? So if this is equal, it should be 1. And then I push it. Oh, but the... Wait, let me try. You could say ça va in 10 different intonations, and it would mean something else in Chinese. No, in French. Yeah, I guess you're right. Like, coucou, ça va? Or you also have, hey, ça va? I don't know. Ça va pas, là. Ça va? Yeah, I guess you're right. Yeah, different meanings. So this one is 4. I mean, I have my idea of why there is... Yeah, I have my idea. I hate it. I know why he's doing that. I know it. It's because the first digit is removed, remember? So this one is actually not considered. And then you have 2 plus a 4, which is 6. And this is 4, so this is not good, actually. Let me print. Oh. Yeah. Let me print. So we have all of this. Yeah, let me check if I can just do byte, bytes, bytes. Can I actually just do that? It seems like I can. Is that what? Ugh, so cold. It's a sequence of integrals. Is it? Oh no. Wait, that's actually so bad. Wait, what? Wait, what? Wait. It's a sequence of integrals? Couldn't you also group the bits into hexa? I could do that, but even if I group them in hexadecimals, then I mean, I could replace it by a character, right? Like the problem is that is the type. It's not like how I represent it. It's like integrals or cutting the end. Well, that's one problem that I can actually fix without converting. But yeah. But yeah, can I just have int 32? Okay. Python int 32. Height type 0から255 a sequence of bytes. A sequence of bytes. Yeah, you don't want a sequence. That's the problem. I guess I can just use a character thing. Right? I hope characters are not just integrals. That would drive me crazy. Like, okay, let's say this is a character. There are no characters, I forgot. There are no characters. I forgot that strings were made of strings. I'm actually going to do it in C++. Like, really, like C++ would be better than this. Like, why is it so hard in Python? This is crazy. This is crazy. But yeah, there's a problem that is not about this. Let's just have if. What's making it hard? I just came back. Welcome back. What's hard is that Python is just cutting my integrals on the left, and it's also what? I mean, I guess that this one is fine. I guess it is. It is. Yeah, I don't know. Yeah, the queue was to iterate over a queue. I had to do, well, I could do queue.q, and the queue that was in the queue was actually a dequeue. That's crazy. But anyway, and yeah, I guess maybe this is like the opposite. Maybe this is opposite day. I guess that's possible. Oh wait, I'm starting I at 1, that's why it's breaking. Oh yeah, that's so... Wait, no, actually this is fine. And I just do a plus. Yeah, never mind. Oh wait, this is a plus. Oh, so I'm not shifting. I'm never shifting this. I'm kind of stupid. Okay, yeah, this is the thing I had to shift. Okay, okay, okay. Okay, this is good. This is getting good. Don't give up. You got this, thanks. Thanks a lot. We're going to do this. We're going to go through this and win. 12. This is the beginning of the success, of the start of my career or something. So we have 1. Every time I'm just checking what bits are. So basically this is 4 plus 2, this is 6. And as you can see, this is obviously a 6. This is not. Ha. This one, oh yeah, there was also the problem of with lists sharing the same array, which is not the case anymore. Let's just remove it just in case. I did it without a queue at all, with a recursive. Just gaslight the machine into working. Shonen mentality. Shonen. Ho ho. Machine-kun, kimi wa mo. Mo. あんたはもうダメだ。I don't know. So yeah. What's the problem actually? Yeah. Wait, let me breakpoint actually everything, every step. So we have this. This is 0. And this is 0. Good. Then I shift. This is 0. Then this is 1, which is good. So this becomes 2, probably. Yep. So then we have this one. So it's going to have 4 plus 2. So this is 3. Well, yeah, this is 3 because the 2 are at the beginning. Then we shift and it becomes 6. 6. Oh, the last one shouldn't be shift. That's why. I'm using recursion, but not to do DFS. How would you... That reminds me of something. There was a time where I had like some kind of challenge, like I gave myself some kind of challenge. And it was basically when you actually make any program without any if, without any while, and without any for. And I actually had an idea, and it was using a recursion for loops instead. And for the break, instead of breaking with a if, like you would do, you would basically look up an array that contains callbacks. And you can actually look up that array with indices, and you can compute the index with, well, the iteration of the loop, right? Machine Kun. Like, wait. Like, I think it's like attack explosion. Or I mean, this was it. I knew it. This is actually the first time I see this word, but I mean it makes sense, right? That's just Lisp. you might not be wrong. You might not be wrong. I haven't coded in Lisp actually, but yeah, to bust out the dictionary. I had to bust out the dictionary. I mean, I did it, but after translating, so that's fine. It's like Baku is the same as, um, so you said Bakugeki, right? So it's like Baku down, because down is like bullet, for example, but like Baku, which is explosion, with down, which is bullet, then you have Baku down. Well, I guess a bullet that explodes. Yeah, that's not really. How can you call that? I guess maybe a missile. And other than that, Baku is also the same as, well, actually, I don't know the kanji, but for the character, but in My Hero Academia, you have Bakugo, right? Like the guy that is like making explosions every time, everywhere. And yeah, his name is Baku because it's explosion. I'm talking about this guy, right? Bakugo. And Geki is attack. So, for example, you have Sogeki, which is sniping. Oh, actually, it might be Sogeki. I think it's Sogeki. Anyways, you have like Kogeki, you have like, uh, I was gonna say Shogeki. Well, you have Shingeki, Shingeki no Kyojin, right? Um, Geki, Totsugeki. A lot of attacks, a lot of kind of attacks. So yeah, this one should be at the beginning. Here we go. Yeah, should be a lot better now. Boom. Let's try. Bakugeki is bombing, I think. Yeah, it seems to be. Well, Google Translate say that, but yeah, I mean, it makes sense too, right? It's basically attacking with an explosion. So, bombing is attacking with an explosion, so it has the same meaning. With the kanjis, I mean. Because, yeah, usually, I guess, naturally, it's just the same as bombing in English. Like, you don't say attacking with an explosion in English, but yeah. Wait, I didn't actually check if this was correct. I actually have some pretty, for everyone learning Japanese, um, let's say Python, I actually have some pretty nice stuff. And this is an extension called, I actually don't know the name, but yeah, this is pretty nice, right? You can actually see directly the characters, the hiraganas, and the meaning. And it's like pretty great. That's like the pronunciation, basically. The furiganas. Bingo. What was that? Sogo. Oh, right. Yeah, I knew that. So Gojo Hosaito. What's that? Interpreter gata no kousui jun bon yo hanyo. Oh, jun hanyo. Okay, because this is the bon from Bonjin, maybe. No, okay, it's a bit different actually. Bonjin is this, so the character is pretty similar, right? There's just like this little water on the left, and that means basically Bonjin is basically uh, someone that has no special ability, and that is just a normal person, unless like a bit of an insult you could say. Well, maybe not an insult, but well, I mean, maybe a little. I'm still on hiragana. I'm not ready. Oh, that's me. Everyone's a bunjin. So anyway, machine. Yeah, I wanted to check that out. This one out. Well, all of those actually. So this one 8, 10. So 6. Yeah, I mean I think this is. So wait, 2. Yeah, this one is 2. So that's great. Yeah, it seems to be fine. And I actually wanted to change up something because I was computing the mask, right? What I actually want to do is have a variable called NB lights, which is an integer. And this is going to be set when passing the input. So new machine dot this equal well, basically this -2. This is becoming pretty bad, but that's fine. The passing, I mean. And now for the mask, instead of doing all of that, I can just have the mask be set at self.nblights, and this is just actually let me think, because I was thinking of doing something like that, but that would only put one. I need, all the ones. So like, do I have a way to compute that fast? Like, for example, 10 is 2, right? Well, no, 11. Can I compute it? I mean, I'm just going to make a 4. I was wondering if I had a solution without a 4, but I'm going to have to do it. So here we go. And the mask, we are just going to add add what? Add what? I guess add y with the bit of, yeah, this I pushed to the left. 1 pushed to the left I times. Should be good. Hey. So now I have all of this. So now the number of lights should be fixed too. And I put, so what if I run? Is it going to work? Nope. Why is that? Mask Y is not associated with, wait, is it? Oh, right. Yeah. 0. Let's start at 0. And what? And 1? And it's like looping forever, isn't it? Yeah, this is looping forever. This is problematic. So wait, this is finishing with a 5. This is now still a 5. Wait, wait, what? Wait, what? This is like never popping? No, this is not possible. So finishing with, oh, okay, 590. Wait, what? Yeah, I think there's a problem with that. Uh, yeah. I mean, you know what? I don't. Yeah, I was planning, I was thinking about making my own queue, but I mean, at this rate, maybe I am. What do you think about it? Oh, so many birds. Uh, yeah, I mean, what can I do with this? Q. 19. So wait, it did remove some. I just have unfinished task. How can I finish the task? It's like going to keep it in the queue forever? Yeah, I really don't like the queue. Yeah, this is really bad. Um, so let's create a queue object with a given maximum size. If max size, I mean, come on. This is not the queue I want. Um, Python queue, first in, first out. So stack Qto queue. So I have the queue here. What is this? Prioritize. Simple queue. Oh, unbounded. Oh, simple queues like advanced functionalities. No, that's fine. I also have the priority queue. Oh, LIFO. What? Last in, first out? Wait, that's just a stack. And then I have the queue with a max size. Give me a simple queue. Give me a simple queue, please, please. Simple queue. Simple. Yes. Yes. So now do me a favor and give me something else, another function shit. Let's still try. I have faith. One. Yeah, the one shouldn't actually be here. And this is 10 already, so there's definitely a problem. What is this? Wait, do I actually have no variable in this? Like, is there anything in there? Special variable? That's it? Wait, what? Okay. Format. Get. Greater equal. Module Q. Size. Ugh, size off. Wait, really? Functions. I guess there's not a lot of functions. I have the empty. I have the put. I have the get, which is good enough. So yeah, what if I try to get... No, wait. I mean, if this is blocked, then... I mean, I guess this is fine. Let's still guess no await. And let's put no await. I don't think it's going to make any difference, but... Because this is a simple Q2, right? So it's probably just reusing the same interface for like polymorphism. So okay, first loop. So we have this is good. Do I have size, a Q size? Built-in method. 5. Because I put the 5 first, okay? Then I add 6, 7, and all of those things, right? Let's continue. 8, 11. 11? Did you watch the... Oh, Game of the Year. I haven't actually. Haven't yet. Was planning to do that, but I actually haven't. Maybe I should have done that on stream actually. But I feel like a lot of streamers actually, you know, popular stream it like too, right? So I don't think that would have been like very great anyways. I think it was during like work time or like during night time for me anyways, so I don't think I really could. Like live, I mean. So wait, from 11 to 10. So I mean, that's good news, right? I guess there's actually a problem with my operations now. So I guess that's a pretty good thing, in a way. I have an idea. So the first one is 3. 1, 2. So yeah, it's saying for the first one that in one tries it's able to do it. So let's check if this is true. We have 1 and 2. Do we have 1 and 2 somewhere? We don't, so it's not possible. So let's go. Okay. Oh, I guess I'm starting at 0 actually. Wait. Yeah, I mean, I don't even need this. Wait, what? Insert? Yeah. So yeah, I actually don't even need... Oh, no, that's the mask, never mind. I thought that was like the amount of iterations. So looks good. NB switch is 1. Okay. Boom. NB switch is 1. State. What? What? So 15 is just before 16, so that's correctly, that's a good mask. But then we have that. And I don't think that's true. Well, I mean, wait, target light 6, new state 6, NV switch is 1. So what's the deal? 12. Do I have a 12? Wait. So I guess this is like 2 plus 8. Wait, this is a 4 plus 8. So this is like 3 plus 2. So we do have a 3 plus 2. And it gives us a 12. Yeah, it's the correct one. Yeah. And 12, and is it... Wait, what is state supposed to be? Switch. Wait, what? So wait, it started with 12? It started with 12. Oh, it's a +1 here. It's a +1 because it's, so if it's there, if it was at the beginning of the while, then it's just 1, but right here it's +1. So now it's 2, and now it's looping. So wait, the first one is correct, I believe. The first one is 2. The second one is 3, and it's looping. Yeah, why is it looping so much? 0, 17. Oh. Maybe it's because of... I was gonna say it's because of the zeros, but this one has a 0 too, and it's working. So... 0, 1. Do we have a 1? We do. Yeah, this one is actually a bit tricky. One, 2, 3, 4. So basically, I guess... Never mind. Two, 3, 2. So 3 is for which one? Second machine. As few as 3 buttons. So 0, 4, 0, 1, 2, 1, 2, 3, 4. I actually have another optimization I want to do after that. But whoa, I already spent too much on this part. So this is 4 disabled, 2 enabled, and 3 enabled. Wait, what? 2 is disabled, 1 is disabled, 3 enabled, 4 disabled, 0 disabled. Yeah, okay. Yeah, let me keep it on the side of my screen, and let's have print. Sorry, that was 0. Actually, 0 and 4. Okay, let's actually check something. So debug. We have this one, which is basically a 2. And the results are 2 XOR, well, let's say this is 0 XOR 0. So 1 0 XOR 4 1 4 XOR 0 1 0 XOR 1 1 XOR 2 1. Actually, this is becoming wrong. Is it? 0 XOR 1 1 XOR 2 1 XOR 3 1. And the final one, you know what this is, and this is totally wrong. Is it? Oh yeah, because I'm making XOR. Yeah, that's totally wrong. So basically my input was, the first one was 0 4. So wait. For every switch. Yeah, I mean, okay, that's fine. I just need a plus somewhere. So 0 4. Let's have this. Let's copy this. It's basically this, right? Then I have 0 1 2. Something like this. And then I have 1. Oh, my bad. This one is my bad. Wait, what? Oh yeah, my bad. Yeah, my bad. 1 2 3 4. That should be the last one. And this is 8. So obviously there's something wrong, maybe, with my logic. Let me check again. Second machine can be configured. So 0 4. This is 0 4. Wait. 0 plus 4. Yeah, okay, this is fine. XOR 0, 1, 2, 0, 1, 2. Yeah, XOR 2, 3, 4. Oh, it's 1, wait, 1, 2, 3, 4. Yeah, that's actually fine. I don't really understand. And 8 is 1, 0, 0, 0. So it's like there. So it's actually the opposite of what I want. Wait, that's actually the opposite, I feel. Because if you look at it the other way, then this is 8, but from there, right? Yeah, this one is symmetric, so maybe that was fine. But yeah, this one is kind of funny. Let me check back what I'm doing. Switch and mask. Okay, let's actually okay, let's actually have some tests. Let's actually do something like print pass inputs. And this is going to be maybe what? Maybe this. I mean, I checked the inputs and it was right? So, I mean, maybe... Oh, actually, I only checked for the first one, I think. Let's restart. Let's check for all the machines. So this one, 8, 10. Final one is 3. This is 5. This is a lot. 8 plus 4. 2 is 4. Yeah, I mean, it seems to be good. What about this one? NVIDIA is 5. Okay. Target lights 2. Target lights 2. Okay, so this is, yeah, this is 1, 0. Wait, yeah, sorry, I got a bit out for a second. This is 2, got it. Actually, for this one, we have 6 directly. Wait, what? Wait, what? Wait, what? This is not 6. This is definitely not a 6. 0, 1, 2, 3. 0, 1, 2, 3. Huh. Oh yeah, this is the last one. So 1 plus 4 is 5. Well, it's not a 6 anyways. But yeah, let's go back there. So we have 29, 12, 17. Oh, because plus 1. So it's 16 plus 1, 17. Yeah, okay, this is good. 7 is 2 plus 1 plus 4. Yep. 1, 2, 3, 4, 5. So this is basically 32 minus 1. Oh, I don't know. Yeah, 32 minus 2. Because we don't have the 0. So this is fine. And 29. 0, 2, 3, 4. So we have everything up until 4, so 16. So that means 31 minus 2, 29. Yeah, 29. So, I mean, okay, this is fine. So that means the problem is not in the values. 5, target is 2. That looks good. So what's the deal? Target light is... Wait, what? 2 plus 4, okay. Target light is now 2. The... Yeah, it's 2. And now I have to check whether there's something for it or not. I guess, I mean, maybe... I mean, no, there should be something for it, but for some reason I have some loop and I don't have a history. So I could add like some kind of history. But do I want? Do I want to? I don't know. Wait, is get retrieving the oldest value from the queue? Yeah. Wait. I think it was simple queue. First in, first out. Yeah, should be good. And yeah, yeah. Let's now try again. So if we have a state of 8, that means we have this. If we have a switch like this is it. Wait, what? Wait, for what? For which one? Which one? What is the target lights? It's 6. That's crazy. That's crazy. Oh, I guess I haven't checked for... huh. You know what? Let's just have... Actually, I'm not sure. State... If 0, we return 0. Yeah, you haven't checked if just new state equal. Let's try to do that instead. New state, so we are using the new state. This is just state. Okay, and this switches +1. Okay. Yeah. Breakpoint. So this is 1. This is 8. This is 8. Wait, can it really happen? I mean, I don't feel like that's supposed to happen. I don't have any machine with that. With 8, I believe. Let's try again. So first one. This one should succeed. Yep. Wait. 3. This is supposed to be 2. Oh, because now I'm doing the -1. Anyway. But, well, I'm doing the +1 there, I mean. Yeah, and it's not working for the next one. Let's try again. So we have this. Then we have this. Right? I think this is the second one. So if I check this, it's 2. That's correct. Why is it so long? I mean, I know it's just a bridge, but 1, mask is now 31, so just before 32, so every element is a 1. Okay, instant, great. Then state equal, okay, is it equal? No, it's not, A. So, oh, okay, let's loop 29. Okay, so here we go. We have 29 and 29 and 29. How? It just switched, like out of nowhere. Wait, what? How did it become 29? Oh yeah, no, the first one is 29. Is it? So it's everything up until 30... It's 64 even. 64 minus... Let me confirm. So 4 is... this. 1, 2... Oh yeah, never mind. Yeah, no, this is not what I wanted. This is 1, 4, 16. So this is 32 minus 2. This is 30. So yeah, this should be 30 actually. One of them, maybe. New stage. Is it like changing values somehow? Zero. It's not. It's 0 now. I mean, yeah, it makes sense. Okay. $17 because it's 29 and 12. And there's the mask. 31 plus 2. Wait. Wait, that's, yeah, 32 minus. Yeah, I don't really understand what's not working. What if I set, for example, that the target lights is now, well, actually, let me have an example. Oh, let me actually just print. In stage. And we have also NB switches. Too many values. Oh no. 5. Yeah, it's just only a lot of 5s. So if NB switches equal 3, continue. Because I guess it's kind of exponential. I set false. No. Okay, that's fine. Actually, if it's 4, we should continue. Okay. So now I have out of those 1, 1, 1, 1, 1, and we find this. That is 1. Wait, actually no. We should find this that is. I don't even know what it is. Yeah, let's maybe put like some kind of targets. Targets. And we have a bin of self dot target lights. So now I have targets. So 110, 110, 110 at the end. So this is fine. What about this one? This is 10, which is great. So 1, there isn't any. 2, there isn't. 1, 0. There's the same elements repeating. I actually have some trick to prevent that, but I'm going to do it afterwards. 1, 0. Okay. One, 1. And this is still 3 actually. 3. No, never mind. Yeah, no, never mind. It should be good. Why isn't it? Why isn't there any? Why isn't it working? Yeah, this is actually a bit concerning. Being careful about my back. One, 0. I just want a 1, 0. 1, 0. Which is this. And we are comparing. What are we comparing? If this is equal. Yeah, I guess equal is the correct one. 2, 0, 0. Wait, what? 0. I guess it's not computed. That's why. Okay, let's just have. Okay. I have an ID. I have a crazy ID. So let's have 0, 4. So let's have if NV switches. Well, actually, let's match NV switches. If this is 1, then if state is not 0, 4, so 0 and 4, so this is 1 or 1. If this is not, then yeah, I guess I don't need a plus. This is just a equal. Equal or equal. Which should be a bit faster, I believe. I mean, maybe. So if this is it, well, if this is not this, I continue. Then I can do the same for this one and this one. And the difference is that I'm going to have 0, 4, 0, 1, 2. I think this has a priority. 1, 2, 3, 4. So 1, 2, 3, 4. Here we go. So 2 and 3. In that case, I should be able to only have basically the correct solution. Oh no, it's not even going in. Oh yeah, not for the first one. I mean, that's fine. I can change it. So when it's 1, state is 17, which is the correct one for 16 plus 1. Then we have okay, let's actually print. Well, we have bin, and we don't have bin self.targets lights. So here we go. How can I? Yeah, I guess that's fine. And now when I do equal, it's not going to work. But then I have the XOR and the mask. So the XOR should basically have a 1, 1, 0. Then oh, but yeah, there's a problem with like if it's wait. Yeah. I'm switching everything. The problem. Okay, the problem is that I'm switching everything. I should not do this. I should only switch the values that are on, not those that are off, right? For the switch. I think that's the problem. because now the next thing is wait, it's never, yeah, it's never this, right? It's like a different thing. If I continue, boom, we have state equal something different. It's not 110, it's 1100. Oh. My nose was talking. Anyway, so yeah, how can I only invest the ones I want? I guess it's gonna be a... Okay, I'm going to take the opposite. Wait. So the goal is I have some bytes. For example, I have this. Then I have something like this. Okay. The goal is to get to 1, 0, 1, 0, right? So basically we are going to take this. Huh. I think we are going to mask it, actually. To mask it? Yeah. So maybe something like we have A, we have B, and we have the results. Or. So we have A. So let's say we have B, okay? This. I invert the bytes. So this is this. I invert. Then I do A and B. So this is this. And then I have the results. So I guess this is actually OR XOR A and, well, that's, well, actually, yeah, not OR. Maybe B XOR A and B equal this. Never mind. So XOR, so this with this. So we have 1, 1. Wait. Maybe it's a and. So wait, let's have, so if we have the XOR, if we have A XOR B, that leads to 1, 0, 1, 0, which is, wait, actually that's wrong, 0, 1, actually, exclusive OR. Wait, no, this one is 0, this one is 1. Yeah, it should be this. I guess that's actually a OR, right? Is it? No. Wait, what? Wait, B is this. This is so bad. It's just the first part and I'm taking so much time for that, but that's fine. Once I get it, then this is good. Good to go. So yeah, I want this, right? Oh, can I just do a plus? I can just plus? I can just plus. I mean, not plus, but it's basically a plus modulo 2 for every bit, right? It's what I mean. How can I... Hmm. I feel like I'm forgetting one thing. One operation. Wait. Yeah, I have... Okay, yeah. What about not end? What is not end? 0, 0 is 1. Yeah, okay. Yeah, my bad. Yeah, I mean, that makes sense. What if I invert that? So let's say we have 1 and 1 is 0. Yeah, basically I just want 0, 0 to be 0. Do I? I guess it's a OR. Okay, okay, you have an idea. This and OR. Okay, you have an idea. So this is basically if the first value Never mind. Ah. So, maybe I can just decompose. Yeah, I think it has to do with like this. Um, let's. Huh. Ah. So. Um, okay, let's write that in English actually. So we have. Let me just poof. So we have step 1. We want to XOR, let's say. And step 2, the parts that were 0 in B shouldn't be changed. Something like that. Oh, so maybe I just XOR, so A XOR B. And now I have a mask. Yeah, but okay, I have a mask and what? What am I going to do afterwards? We the pots. We have A. This is so trivial, but for some reason I just can't. So 0, 0 equals 0. 1, 0 equal 1. 1, 0 equal 1. 0, 1 equal 1. I mean, yeah, this is literally XOR. No, this is not XOR because of this. Exclusive OR. Oh, no, this is XOR. Wait, why am I thinking so much? This is XOR. Because it's exclusive, right? Well, yeah, but in my case... Yeah, wait, it is XOR. So 1, 1 is 0. 1, 0 is 1. 0, 1 is 1. 0, 0 is 0. Yeah, that's XOR. Yeah, so what? What's wrong? Is it the mask? Let's try again. So we have state. Wait, state? Am I modifying state at any point? I don't think so. Plus, yeah, and that's like an integer is supposed to copy, right? So state and switch. Why is that even? So 4, state is 0, 1, 2, 3, 4, and 1, so this is correct. State is correct. Target light is this, 10, so this is correct. 2 should be 0, 1, 2. Actually. Oh, yeah, never mind. So this is 1. This goes in 1. Yeah, this is actually fine. And 2 is 17. 6, 1, plus 2, 3, plus 4, 7? It should be 7, right? Am I crazy? Yeah, it's going to... Yeah, okay, it is 7. What if I bin that? 1, 1, 1. Yeah, I mean, okay. What about... Yeah, what is state? Yeah, state should be... Oh yeah, state is 17. So yeah, never mind, this is fine. And this is... This is fine. State XOR this. So if I XOR that, everything is going to be put to 1, except the start and the end, right? So like 3 values. This is new state. I mean, never mind. I guess this makes... Never mind. So this becomes 0, this becomes... This doesn't become 1? Zero. Oh yeah, never mind. Never mind. Yeah, never mind. This is good. Yeah, I mean, yeah, never mind. Then 1, 1, 1, 1. Then we have 0 because it's switching. Okay. So this is 1, 1, 0. Wait, what? Wait, it just finished computing. It just printed. Okay. So now we have 110, right? 7. State. Why? Yeah, because I guess it put a lot of stuff. That's fine. But yeah, one of those should be at least what I want, which is... So it's 1, so... This? 7. Oh, yeah, wait. Let me switch is 1. I guess it's the next one. I guess it has to rotate. But I have to wait, basically. Boom, here we go. So 7. Is it 7? This is 12. Okay. Yeah, let's just check here. Yeah, I mean, I can't, right? Of course I can't. So list next state queue. Oh no. No. Okay, I have an ID. I have a secret ID. Q.Q. No. This is not working either. Continue. Continue. So its state is 0. Wait, what? Wait, state is everything off, okay. Yeah, I mean, makes sense. I need a 7. What is 7? I forgot. I mean, this is just state. Yeah, it's not going to work, isn't it? Yeah, maybe if, just for debugging, maybe I shouldn't have started with the XOR. But this is crazy. So yeah, it said that it was... Is it actually the correct thing? Because 04012. Okay, let's check. 04012 and 1234. Okay. Oh yeah, because I'm checking the state. Oh, I'm so stupid. Yeah. Yeah, okay, I get it now. Yeah, okay. My bad. Wait, so it really isn't working? Because yeah, I just have to check for the switch. This is the switch I don't want to add. Okay, it's getting here. So now let's switch here. This is it. And +1. So maybe I should just 0, 1, 2. Let's go. If this is 1. Yeah, but I also want to check it out for for this. I mean, I guess this is just this, basically. So I should have 6, 7. What is state? State 17. Now I continue. Case 1, 29. And in any case, this is 20, never mind. This is 7, and I should have a switch with 7. So I should be able to go there. Okay. And now I should have, what should I have? Let's see. So you have state 17, switch 7, 17 and 7. Bin 17, bin 7. So this and this. Then we have 1, 1, 1. And when we XOR, we are getting 22. Which is this. I guess we also mask, right? With 31. But let's say we have this. That means we have that. And that looks correct. I mean, that looks good to me. Yeah, this is XOR. Yeah, of course it's working. Of course it's working. Okay. And next we have the next one. Oh no, no breakpoints. Okay, what about now? Yeah, now it's working again. So now we can loop again. Boom. Okay. State NB switches. Now we should get to 2. Boom. Okay, so now the state should be correct. So 22 should become 8. What is the target? It wasn't 8. Wait, 22. And what is the switch? The switch is this. Wait, what? State switch. So state was that. Switch is this. And the result is new state 8, which is this. Oh, because there is that. Oh yeah, okay, it makes sense. And it's saying that it's not correct. What's yeah, that's wait, I'm losing my head. I'm losing my mind. So that's 3 buttons. No. 0, 4, 0, 1, 2. Okay, let me try that. So I have I guess 0, 4. XOR. XOR? Oh, never mind, wait. Actually, yeah. XOR 1, 2. Wait. 0, 1, 2. 2. XOR 1, 2, 3, 4. 1, 2, 3. 4, right? And this is 8. Yeah, this is 8. Yeah, I mean, yeah, this is 8. Wait, I'm not sure I understand. Yeah, let's do it one by one. So you have 0, then you have this. Then let's say you do this. Oh. Let's say you do this. Then you XOR. So you get this. Oh, I mean, you get all of that. One, 1, 0, 0. Wait. 1, 0, 0, 0. Wait, what? 0, 4. Okay, ouch. Oh yeah, I'm not touching the last one. Yeah, okay, this is normal. This is fine. Let me just put this one back. And our goal is to I'm inverting, that's why this one was symmetric, so that's why it was correct. But this one is actually, it's correct, but it's symmetric, it's a symmetry. I got stuck on part 2. Hey, welcome! How's Sata? Welcome. You got stuck on part 2. Yeah, it just got unstuck. Probably thanks to you. You brought me some luck, so thank you a lot. I appreciate. Yeah, this is the opposite. This is opposite day. Huh. Interesting. I don't know what I should do. Yeah, why is it the opposite? Part 2 of day 10 is really hard. Huh. Yeah, I got told that, but I still have to do it. I am still finishing part 1. But yeah, I just want to optimize a little. And yeah, why is it like the opposite? It's like 8. Let me look at my parsing. Why am I doing that? I forgot. Oh no, this is so stupid. Ah, this is so stupid. No, no. Oh, that was so stupid of me. I just forgot to remove some old card. And now this is 1, 2, 3. And nothing. Shit. And most people just used a linear solver for part 2, but I feel that's cheating. Oh. Is it? Oh, sorry. Let me watch. Yeah, so 1, 2, 3. And wait. Let me put this one and restart. Yeah, so the first one is... Actually, I think the target was... Okay, first one is target is 1. Is it correct? Obviously not. Uh-oh. Yeah, okay, never mind. I do need this, actually. Yeah, I do need this. Or I mean, I can just move it directly here, basically. So this is that. Like I. This is the opposite of I. Let's restart. Or maybe that's why. Oh, yeah. Wait, 0? Yeah, that's probably opposite day. Yeah, I might give it another try. Maybe I should let it run overnight. No. Yeah, maybe not the best solution, if that's the case. I actually have another optimization for part 1. I talked about it, but yeah, I just have to fix this part. Okay, let's verify. Is it correct? 2. This is correct. Yeah, I'm just getting the opposite. I mean, I could, but... Like, I'm trying to find the logic, because... This is correct, like, this is giving me 2. Wait, is it? Wait, 2? Yeah, 2. So, like, 1, 2. So this is, like, the 2, right? The 2 I want. This is the correct result. This is the integral representation that I want. And... Is it Python? Python is not using. What is this? Yeah, that makes sense. Isn't that bit free? No, it's like 0, 1, right? Is it? Because I'm getting the character. So I'm getting the first character. Okay, so this is the first character. If this is equal, then this becomes 1, okay? So I'm adding 1 to the string, if this is, and then for every other iteration, I'm pushing it. So that means it becomes this, right? Then this, and then maybe another 1. So that should mean this is at the correct place, right? Let me check my code again. Okay. Because, I mean, this makes sense. Like, yeah, this is my representation. Well, that's how I've represented things in my head. And, like, the target light looks correct too. And if I go here, happened, I have the switches, which are 29. Like 7. Okay, 7. This should be 7. Oh, but yeah, what's actually 7? Yeah, because that's the difference, I suppose. I suppose. 1 plus 2. Yeah, I mean, yeah, that makes sense. So the reason I reversed was because I converted to 0 and oh, and sharp to 1 from left to right. They had to reverse the string before converting to base 2. Never mind, you're right. So yeah, why is it opposite day? This is crazy. So I actually want to check with something that is not symmetrical. Oh. Wait, I might have an idea. Yeah, I understand why. Do I? Maybe I don't. But maybe when I do the XOR, what if I do that XOR um, that? What is it giving me? Yeah, thanks. 7. Okay, let's bin that. Python, tell me. Uh, yeah, I mean, I guess it's kind of what I wanted to, right? So, I mean, I guess that's fine. Is it because of the end? Because I just put a random end somewhere. What if I remove it? Well, not random, but just wandering, right? Like a mask. Like this here. Oh wait, maybe that's just the second iteration. Well, maybe actually this is good. Total is 0. No, this is not good. Yeah, and it's false. because state is, I don't have state. I have state still. No, I don't. So yeah, I tried to follow, but it just didn't work, right? Like I tried doing the operations that they were saying we should do. Oh yeah, because it's different for them. Oh yeah, yeah. Okay, I get it. It's okay. It's not a problem of my code being wrong. It's a problem of them being wrong. Just kidding. It's a problem of the indices, right? Yeah. As I said, for me, I started from right to left, but they don't. They count from left to right. That's why it wasn't a problem of my code. I guess it wasn't a problem of my logic directly, but it was a problem of me understanding the. Well, actually, I guess I understood the thing, but I don't know. I just kind of got mixed up with bits, I suppose. So yeah, this is it. So I have to mix it. And yeah, I guess this is what you said. I converted to 0 and never mind. Yeah. So yeah. Okay. Yeah, you're right. So wait, what is it actually? So the first one is oh. The first character is the last one. Is it? Wait. But it's 0, so okay, bits become. Yeah, I have to invert. ID 0 is on the. It's not on the left anymore, but on the right for bit operations. Yeah, this is it. And I have to reverse, basically. Okay, so I guess I should start from that -2 and go to. Wait, do I actually have? Because I want to. 'I guess this is the new one that I want to move, right? Not the previous one. So I guess this is this instead. It should be it. The first one is 0, so that should work. Okay, yeah, that should work. Or not. Zero. Um. I have one more than I need, I think. Oh yeah, because I'm starting at 1. Um. right? Let's do. Ah, I minus 1. Okay, now this is it. Are you ready? Are you ready? I spent so much time on that, but that was so stupid. Oh. Oh no. 3. What's... Let's actually reverse again. Oh yeah, I mean, okay, yeah, now I have to remove all of my conditions. If this is equal, then okay, we do stuff. Let's remove the prince, because now everything should be good. Yeah, now it should be good. 7, and it was... 7, so yeah, this is good. Okay, now it's time for my optimization. Are you ready? So this is quite simple. Basically, as I told you before, we have 0, then XOR A, then XOR B. This is equal to 0, XOR B, then XOR A, right? So what that means is that I don't want to run both, basically. And what I can do is specify that only A, well, that's what? That from B, I only run A if this is... if B is less than A, basically. Okay? There's like some kind of comparison. We have to basically compare. It doesn't matter whether the condition is like bigger or less. It's basically so that we can remove one of those. And if, for example, the solution is 0 XOR B, XOR A, XOR A, for example, then this solution should be equal to this one, right? So that means we can remove this one. Like every time B is like less than A, like B for A, right? So let's do this. And what I want is basically we have... that means I have to conserve the current switch, right? I mean, basically that works with indices, that works with the switch values themselves, but that doesn't work with the states. I just have to compare. I just need a comparison. Doesn't matter what it is. So I guess, I mean, I is probably not... let's put a last switch. Yeah, let's switch. This is fine. And last switch is going to be switch here. Yeah. This is going to be the switch. And now I have to compare. I mean, never mind. Let's actually use indices because then we can... yeah, never mind. We don't have to put ifs here if we put indices. My bad. So yeah, okay. So the index for this... well, that. yeah, let's have indices. Range. So len of self dot switches. It is going to be I. And we are going to have I. Here we go. Then now this is, I guess I need a new thing. Last switch index. Okay. Then we have this, which is going to be I. Here we go. Let me just put this one there. And we have a for I in range from the last switch index to, well, to the max, right? Here we go. And now we don't even have to if that. We start directly at the correct index and we prevent like a lot, right? The only problem is we don't have the switch. So here we go. And now it should be like a lot more optimized. So let's run. 7, okay. Let's run input. Yeah, now it should be like so optimized, like incredible. Okay, 385. This should be the results. Let's try that. Are you ready? Boom. Working. Here we go. Okay, so what's that second part everyone is talking about? Oh, the machines are starting to come online. Hey, now it's time to worry about the voltage requirements. Each machine needs to be configured to exactly the specified voltage levels to function properly. My mind suddenly went boom. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the voltage levels. What? Ignore the indicator light diagram. What? Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights okay. The machines each have a set of numeric counters. I'm lost. I'm lost. I lost it. Machines each have a set of numeric counters. Tracking its voltage levels. 1 counter per voltage requirement. The counters are all initially set to 0. So this, right? 1, 2, 3, 4, 5, 6. 5. Wait. 1, 2, 3, 4, 5, 6. 6. Okay. Okay. So voltage requirements like this mean that the machine has 4 counters, which are initially 0. Okay. Wait, does it? Oh yeah. And that the goal is to simultaneously configure the first counter to be free. Second counter to be 5, the third to be 4, and the fourth to be 7. Congrats! Not sure if you had already considered it, but for next time, what do you think happens to the result if you XOR over the same bit string S multiple times? Like S XOR S? I mean S XOR S just... Wait, let me... I mean, everything is equal, so it should become 0, right? It's like canceling itself, right? So then if you XOR again with the thing... Oh wait, no, string, right? The same bit string. I mean, yeah, that's the same thing anyways. It's XOR. So without XOR is like S. With the XOR, when one XOR is like 0, one another XOR is S, one another XOR is 0, and all of that, right? Right? So the first counter to 3, the second counter 5 to 7. Button wiring schematics are still relevant in this new voltage configuration mode. Each button now indicates which counters it affects. Now indicates which counters it affects, where 0 means the first counter. Yeah, this doesn't really change. When you push a button, each listed counter is increased by 1. Okay, yeah, okay. Yeah, okay, yeah, it's this thing. Yeah, got it. So button wiring schematic like 1-3 means that each time you push that button, second and fourth counters would each increase by 1. Okay. If the current voltage levels are this, pushing the button will change them to be 0 to 4. Current voltage levels were this. One, 3. Yeah, makes sense. You can push each button as many times as you like. However, your fingers is getting sore from all the button pushing. And so you will need to determine the fewest total presses. Wait, okay. The fewest total presses required to correctly configure each machine's voltage level counters to match the specified voltage requirements. I have, wait. My head's just... Consider again the example. 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5. Okay, this is the test. Okay, this is really horrible. I just hear myself cracking. I just crack a lot. Okay, be right back. I'm gonna try to drink. Okay, sorry, I'm back. Am I? I suppose I am. Okay. Oh, you're still here, everyone. One, two, 1, 2. Okay, I'm probably a bit better. Maybe it was just realizing it that just made me really weird. Or is it? I don't know. So, okay, we have a lot of things to do. Do we? Oh, wait, I actually did this one already. I mean, I think I already had this one in another, like on lead code maybe, or like another thing. I already did this one. So yeah, you just basically have to, I mean, brute forcing is fine. Um, brute forcing is fine. I think. Let me check the values. Um, so we plus, right? And we just have to curl. Yeah, this is fine. This is actually just using what I did before. So wait, what was it? Target light. Um, wait, what do I have to change? That's the question. So this is... Oh, okay. This is a counter. Yeah, I guess we're going to remove the whole bit thing, right? Instead, we are going to have switches. Uh, I could call that bit machine, or I don't know. I mean, this is for the first day. Let's just remove everything that's not the first part. I mean, let's remove everything that's not really needed. Boom, boom. Okay. Oh yeah, you don't have the cache. I mean, I can still use the cache. Can I? Yeah. Um, we can use cache to prevent computing again the same for the same states. That's it. That's all. So I mean, in the same sense, we can use some. I mean, yeah, this is DP, right? Is it? Do we even need DP? Yeah, let me check. Um, yeah, DP. We do DP. Probably. Yeah, DP is going to be great. Probably. Let me think. Minus. Yeah, this is DP. This is DP. We need a table, and we are going to use DP. 200. Um, So yeah, we're going to start from the end, actually. We're going to start from the end. Machine... Let's call it bit machine? I don't know. Day 10... Yeah, bit machine. Yeah, it's actually pretty simple. So let's say we have this. Then we have... Yeah, let's just keep the same. We have this. The number of lights. I mean, all of that doesn't really matter. Target lights. Okay. Switches. It's a list of int. So we have a list of int. NB lights. What's this thing? What's this? You can hear me? Okay, that's great. NB light is not needed, and we have targets. That is a list of ints, right? Yeah, that's pretty simple. Now let me think. um, this is just a machine. Machine. So we have the same, but we don't count that anymore, right? Had to reverse, yeah. And we still have the switches, but instead this is a list of integers, and we append the number. So this is the switch that we add. This is an empty array. Okay. Yeah, okay, I'm better. Good. So we append. At the end we have another, here, we have another line maybe, another loop, another, let's check, what is it? Not that, this. So yeah, it looks like that. So this one is, so we don't check the first and the last, and we get the numbers inside. So this is the same. The same as, wait. As this. Targets equal this. Okay. Yeah, just making sure that we don't share the same array, right? Now I'm just going to take -1 because this is the last array. I remove the brackets. I split where the commas are. This is not a switch, this is a count targets. Well, I mean, this is just targets, right? I don't need this. Here we go. Yeah, here we go. And now if I day 10, I mean, what am I supposed to return? Wait. Okay, configuring the first machine, 10, a minimum of 10, minimum of 12, minimum of 11, then I add, and then this is it. Yeah, good. So this is the same syntax, basically. What is the same main function? Minimum iterations, all of that, for each machine. What is that? Oh, it's a ban. Okay. Find minimum iterations. Okay, let's first check if this is, if the parsing is correct. Boom. Targets 24. Oh wait, that's, well, 2417. 2417. Yeah, okay, that's fine. Should be good. Should be good to go. Let's just use the test input instead. Now I have this. So I have my machine. I can just basically just copy that. I'm just going to actually, never mind. I'm just going to copy it for now, but it is going to change. So yeah, I can just push with a queue. That's a possibility. And use a set to like memorize what I shouldn't push again. Like do some memorization. But if I minus, I mean, I could use multiple arrays for each of those things. Should I? Or should I just use one big array? I guess cache-wise it would be better to just use one big array. But I mean, I don't really want to... I mean, I'm already overkilling it, right? So that shouldn't really matter anyways. So the complexity is basically going to be 200, for example, in the max case, max scenario. The 200 times the amount of possibilities that we have. So, for example, 8 times the amount of switches per possibility. So, for example, 4. And I guess that's it. So I mean, it's not that big. Wait, is that all? I think that's it. Yeah. Yeah, that's it. So yeah, that's nothing. And we don't need like any ifs, any of that. Well, I mean, maybe a little, but yeah. So let's just remove all of this. We're not going to have a queue. Yeah, my bad. I'm just thinking. But okay, yeah, that's fine. So let's have some DP array. That's going to be a list of integrals or multiple lists. I guess let's go for multiple lists. Is it how you do it? Like, no, never mind. It's a list of lists. I don't like that. It's a list of integrals, a big one. Let's get the max height, maybe. One big array for a big cache boost. One big array used as a 2D array. So we have DP. The maximum haste is more like, yeah, haste is good. Well, I use that visually, like in my mind, so that's fine. So we have the target, and I basically want the max in this, so math.max, yeah, okay. Let's say this is 0, and for n in this, then this is just going to be the max between this and this. And that means that now that we have the max, I can do this. I have the array that is a list of integrals. Let's initialize everything at 0. Or actually, maybe -1, or maybe yeah, actually the maximum, so that we don't have any other if, any other condition. Where was that? Int. I think I used it like recently. I used that like limits. I'm not finding it. Let's check on Google. Python max int. Python. Max int value. Oh, system.maxint. Right. So sys.maxint. Maybe not. I mean, in any case, I should import sys, right? Max size, maybe? What's that? Oh, that's actually... I guess there's no maximum int. Huh. what was it again? Sys dot. No. Oh, it's float info dot max. Okay, so what about int info dot max? Okay, so there's actually no maximum for integrals in Python, I think. So what about the giant value? Let's have max amount, because let's say we had let's say we add everything one time. That means it's like just times, right? Max amount, what max combinations? Start at 1. And we just multiply by n every time. So this way we have the maximum value. Can be max combinations times max haste times the width is, let's say, width equal self dot target, and this is just the length. So this is this times this. Now what we are going to do is, we have the target. We are going to start at the target. So let's just choose the things of the machine, okay? Let's just modify the machine. And we are going to, well, these are the indices. So let's just loop over that. For each what? Well, I mean, while targets basically doesn't have any more zeros that are, well, is target reached? Is target at 0, maybe? What should it be? If it is past, in any case, we should stop. But I don't want to loop through the target list like multiple times. I don't know if I can like prevent that. Oh, I can probably, actually. I mean, I was thinking of multiplying, but I guess that's not what I should do. And what else can I do? Oh, if one is less or equal to 0, then I stop and I return the sign of this. Never mind. It's not going to work if I have some values at 0 and some negative. Tricky. Yeah, I need everything at 0 anyways to stop. Okay, okay, let's target at 0. Well, this is not the case, we continue. Okay. Then we have if has negative, well, has all targets at 0, has negative targets. If it does have negative targets, then we just continue. And then, oops. Anyway, we have stuff, right? And then if not, what we are going to do is we are going to loop through every switch in set.switches, which is a list of integrals, maybe. Is it? Okay, maybe I can't specify it. Too bad. And then for every offset in a switch, let's say, then I'm going to have the current. So wait, machine. Oh, right. I have this thing. Oh yeah, but it's DP, right? It's DP. Oh yeah, so if it's DP, it's actually very different. Yeah, it's very different if I do that in DP. Yeah, okay. My bad, I was forgetting. So let's start at, well, just, yeah, okay, this is actually very simple. I in range, well, actually just targets. So it's like, can I, yeah, let's rename that targets instead. And let's modify this. Here we go. So we have 4 targets in targets. We are just going to set this to 1 because we only need 1 combination to reach that, right? Set the targets. So like for example, if we start at 0 and the target is 5 and we have wait, let me think. Never mind, maybe it's actually 0. Yeah, I think it's probably, yeah, I think it's 0 actually, never mind. Yeah, if we are already at the target, then we need 0 combinations to be at the target, right? Makes sense. So okay, we have this. I mean, I guess we can always use a loop if necessary, but that's fine. Now for, let's have something like I and j, maybe. I for the row, j for the column. So I equal, actually, I guess it's just j, I just need j. Actually, actually, yeah, I guess a queue is like better in the end. But I mean, the DP array is still helping. Wait, should I do that with a queue? Or I actually don't really know. I'm actually wondering. I mean, okay, let's do it first with DP. So let's have I equals 0. Then we have j equal max height because we start at the top, maybe. Sounds good. I mean, we could do the opposite though. We could start at 0. Um, I mean, I guess that would be like even easier, right? Okay, let's start at 0. Let's start at 0. So we have for I in range, well, for I in 4. So width. Then we just have dp I equals 0. And then this is basically the first row, setting first row to 0. And then we have for j in range, so this is a max height, -1. Oh, this is not going to work. This is not going to work. Because I'm kind of doing that like independently, right? Yeah, for the DP I was planning to do that kind of independently, but it's actually not independent. Wait. No, never mind, this is actually fine. Is it? Wait. Amount of combinations. The problem is how do I update the DP table? Because if this is the amount of combinations, yeah, actually this is possible. Is it? No, this is not the amount of combinations I thought it was, kind of. Uh, yeah, because it's not just going through the queue, it's, well, the beginning should be 0 if I go through the top 2. So wait, is there really no DP? There's probably some DP somewhere, but I don't know where. Yeah, then it's branching. Um, yeah, okay, maybe there's no DP after all. Never mind. My bad. Yeah, there's no DP. Yeah, okay, fine. There's no DP. So yeah, let's just have our queue. Well, this is not the case. while this is not the case, we have the Q, what is, yeah, simple Q. Yeah, because I think I had a similar problem, but it was only with one value instead of a list. So with one value, you can very easily do some DP, but with multiple, I think you can, but that would be complicated. Anyway, I mean that's still going to be fine with a queue. There's no reason it doesn't work. So this time, what is it going to be? It's going to be a list of ints, maybe. So yeah, this time we don't want the breadth. Yeah, okay, good. This time we don't want the breadth first. This time we actually want a depth first, probably. Okay, in this case, we have to be careful. Or do we? I don't know, actually. No, that's fine. So we have depth first search. That's damage per second. And we're going to have the list. Well, we're going to have the state. And last switch ID. Well, index. That's how I called it last time. And this should be fine. What did I have last time? State NV switches. What was that? Oh, this is the amount, right? So I mean, yeah, I should have this too. NB switches? I guess it's not a switch anymore, but yeah, that's fine. Okay. So I'm going to do this. Instead of the as negative target sign, I'm going to not push in some cases. So okay, has all targets at 0? If yes, well, if not, we continue. If yes, then we finish. And we have okay, I guess this is a while true, kind of. This is fine. Is it? I guess. So it's a list of integrals, the state, the amount of switches, and the last index of the last switch index. Okay. And it's just going to be while there is something. So len is not 0. That's a lot better than using that q. That q was really horrible. And while this is not 0, then we are going to pop the last element. and we have state, we have the NV switches, we have last switch index here. So we just have to, you know, put the first, I mean, I guess we are starting at 0, right? So yeah, let me, that should be happened. So this is just 0 times length of self dot targets. Then we have NV switches 0, and last switch index, let's say this is just 0, right? It's not really 0, but this is fine. Oh, cold. So we have this. Now for every switch, I mean, I guess we can verify, right? If state is 0, basically, we return, well, we are set here, and we return NV switches here. Then we have last switch index. So instead of doing that, we have, wait for, yeah, so for I in range, this, and we start at last switch index again, same thing, right? Same thing. So then we have the switch, which is just self that switches I. Wait, what? Wait, what's... For switch, and we have the increment. Wait, what? I'm getting multiple falls, I don't know why. I think I don't need this one. And this is an offset. Yeah, okay, this is good. And we have the offset. So now let's... I'm just thinking because there are there's memoization, right? So when there's memoization, like a lot of the times you can just DP that. Yeah, I really don't like how I feel like I can just DP. Oh, wait. Amount of possibilities to reach. Let's say I start at 0. Then for everything I add this. Yeah, but I have different states. I don't have like possibilities. What about what if I start at 0. I had all of them. That becomes one possibility. Then I go up the next line. I do the same. I actually don't know there. Because it's like unlimited, right? So it actually doesn't really matter anyways. Then I go up. I do this again. Yeah, never mind. Okay. So offset. Okay. I'm going to have so many lists, I feel like. I guess, well, I mean, yeah, I guess we're just going to get destroyed, so I guess that's fine. Okay. Next state, we can call that. This is just a copy of state. Can I clone? Python list clone. Copy. Wait, can I? Copyright. Copyright. I mean, I guess. This lists dot copy. I mean, I guess this is just because it's not explicitly a list. So now let's state dots, please. Oh, wait. Expected expression. Nope. This is just what I wanna do. Oh, okay. No, never mind. No, it was not close. It was okay, I get it. We have this equal dep 0. We have this equal dep 1. And we have this equal dep 2. Is it good now? Yeah, it is. So state that copy this time. So I have the next state. Now I can just wait. For I in switch, then I just I plus equal switch I. This. And if this becomes higher than the targets, then I what? I mean, I just don't add it, right? But I guess I wanna make a function. I like making functions for that, but I guess I won't necessarily be able to. So if this is bigger than self.targets I, then I break everything and I don't add. Okay, function. Okay, fine. Should add equals true. This becomes false. I can actually optimize this, but that's fine. We can, use bitwise operators, but that's fine. And then I break. I forgot. A little more performance. If should add is... Oh yeah, because I don't have to... Wait, if I do breath first... Wait, breath first versus death first. Which one is the best? Because breath first I can just... I mean, death first is actually not very useful. Because, okay, I would reach the targets. But then what? Then what? Then nothing. But if I do breath first, then I mean, I'm going to have a lot of potential elements. But the first one to reach the targets is always going to be the first one. So I can just curl everything else. So death first is actually a trap. No, my list. That's fine. I can just replace it afterwards. So if I should add, that's it. Then I have next state. Yeah, I mean it's still called Q, so that's fine. State. So we have next state. We have NB switches, which is NB switches plus 1. We have last switch index, that is I, right? I mean, I guess that's it, right? Nothing too complicated. Actually, that's kind of what we had before, but in non-bit version. So we add Y. Y. Yep. And we have the culling with the last switch index, which is great, honestly. Let's have a static, actually never mind, is list 0. L, let's take the L. And we, for E in L, if E is not 0, then we return false. Else we return true. I guess it's machine. I mean, it's not really machine, but okay, fine. So we append only one time each. Then I guess we will breath first instead of death first. Yeah. So we have the Q. I don't have a queue. Wait. Oh, pass. Yeah. We have the simple queue. That is not simple. Not there. This. Oh, wrong one. Day 2, this is actually a machine. Machine, okay. Then we have... Okay, I actually kept it here, so I knew what was going to happen. Empty. If this is not empty, we continue. Then we actually get no wait. And here it's going to be similar, it's going to be put no wait. I don't want to wait. State, copy. It's a put no wait. No, wait. I actually want to try something. Or maybe not. Maybe I do. I actually want to sort the lists. Never mind. Never mind. Yeah, okay. Should be okay. That's good. So let's say we have this. Is it good? Wait, actually, is it the end? I mean, we can try. I feel like I'm missing something, but I don't know what. 0 is equal. So what's happening? Why such delay? So state is... Oh, I mean, yeah, it's already 0. Yeah, okay, my bad. My bad. So is... how can I do a deep comparison? Can I in Python? Python list deep comparison. str. Boom. I mean, okay, let's do is equal. So let's have B. I mean, I think it's faster to compare with 0, so the ideal thing would be to go from the target and try to get to 0. That should be more efficient, but I mean, that's fine, right? We don't really care about that. For I in range, length of A, let's say. Yeah, let's not asset. I don't want to reduce the performance. If AI is not BI, then let's return false, and here it is. So state with self.targets. I guess it's like has reached target or something. But anyway, let's debug. False, okay, good. No, not good. Okay, what switches? Oh. Yeah, what switches? Oh, self that switches. Ah! I don't know why, but it's like just really slow right now, my IDE. Maybe I should like just restart. Self.this. Okay. So what was test input. I mean, I guess I can just put self. Switches is 313 2302. That's correct. 01. And 3547. That's great. No, wait, the target was 3547. So why? Why not? If next state is bigger than self.targets. Yeah, that's fine. I mean, it looks good to me. What is it saying? You know what? Let's just have actually a custom input. Let's just have some dummy value, I suppose. Let's have... I guess I actually don't want a dummy value. But let's have 1. Let's have 4. 0 and 1. 0 and 1. And... yeah, 0 and 1. Well, 0 and 2. Wait, I don't know. Wait, I just realized. Wait. Bumping 1 bumps everything, right? So I guess I can actually curl some values. Possibly. Oh, wait. Yeah. Oh, wait, I just realized. It bumps only 1 time, right? Wait, what? Wait, I got it all wrong. I got it all wrong. Oh no. I got the problem all wrong. It's not plus. Oh. It's not plus. I got it all wrong. The whole problem. It is a plus. In my head it was this, because I saw a similar problem before. Okay, DP. Can I DP that? One. If I start from 0, it's really going to be too much, right? But I mean, no, DP would actually work. DP would work. DP would work. Because this is the minimum to get to a place. Yeah, DP would actually work. And yeah, it would be like a lot better than that. IT. Let's do it again. Okay, yeah, I didn't take into account that it was like +1. So I actually have to I have to do it again. I mean, I guess that's fine. So dp equal a list of integrals, which is minimum combinations to reach there. Therefore, I in a range from 0 to, so I have self that's targets. I get the length. This is the width, and the height is, as I said, the. I mean, I guess I'm just stopping when I reach. Am I? Yeah. Okay. No. Okay. So height equal 0 and for targets in self.targets, x equal max targets and eighth. So now I have this. I loop through the width. This is going to be 0, right? Why is it green? Anyway. And now for j in range until, well, all the heights. Then I do for the width times the width. So it's I. And what I'm going to do is, I guess I'm going to start at 1 here. J times width. So it's like dp. Let me think. Let me start at 0. Let me start at 0. And let's finish at eighth minus 1. Okay. Okay, feeling good. Feeling great. So we have dp j times width plus I equals something new. That is going to be the current thing, the current I. Wait, width. Let's actually, instead of width, I guess we can just, yeah, okay. Instead of width, we can just go through the element, which is offset, for offset in self that. I guess I have multiple of those. I mean, does it really matter? Okay, can I optimize this? For every switch. Oh, right, never mind. Oh, wait. Okay, DP, okay. I was going through the DP path again. And I was once again getting into problems. Yeah, maybe DP is not possible. Getting tired. Because if I do DP, then okay, let's say I add one everywhere. And this is nice, right? But I mean, then the result is just going to be the sum of all the ones. Something like that, yeah. Wait, one. Okay, this is fine. Let's do it the iterative way first, at least. I don't think there's a DP actually. For the same reason I didn't think there was one before, but for some reason I decided to change my mind. So we have all of that, then we have the plus equal. For switch, okay. What's great with a tree is that you don't have to copy. But it will be like really recursive, so anyway. What? What's that? Okay. Okay. So plus one. If this is higher, then we'll break. And okay, let's try again. What's for every switch? Oh, right. Yeah, okay. Am I using I? Yeah. Oh, I have two I's. Oh no. So this is actually the offset, right? Yeah. This is not an offset actually. This is ID in switch. Next state ID plus equal 1. And I compare. And I think this is it. Index out of range. ID is 1. Next state is bad. Why is it 0? Tuple. Oh no. Oh, because of this, is it? Am I doing an extend or put? No, wait. Next state. Okay, I'm doing a copy. And I'm pushing the state. Wait. State. And this switches last. Okay, so this is the first one. And state is an array containing 0. And this is an array containing 0 because target is just 4. Target is 4. Wait, target is... Oh, right. I forgot about that. My bad. Here we go. 33. So is it the correct answer? 33. I mean, maybe. Okay, I just had to do like 2 modifications and that was it. But I decided to go with DP for some reason. So yeah, and this is like for everything. So let's just test input and let's see if it works. And if it doesn't, well, if it's too slow, then we have to add memorization, like definitely. Let me actually, okay, here. Let's have a print like there. It's a queue, so that's fine. Let's have a if this 5 equals 0. In debug mode, yeah, I know. 5. Okay, maybe that's... Okay, never mind, that's way too much. It's going to take some performance. Last print index. If this is not this, then we print and we assign. Basic. So 1, 2, wait, why? Wait, why? We put... Yeah, it should be breath first, right? Why is it that way? 5, 4, 5, 4. I only have one print, right? Yeah. Oh, my bad. Wait, no, never mind. Let's switch. Yeah, this is crazy. Oh no, it's the switch index. Okay, it's the amount of switches that I want to compare. So it's not indexed, but that's fine. Yeah, this is done. This is for inputs, right? Yeah, with all of those, it's going to take a while. For sure. So now we have to optimize. What are we gonna do? How is it going? Hey, Alfish Creature, how are you? How are you doing? Me, I'm fine. I just did some not very optimized thing, let's say. I mean, a little optimized at least, but yeah. And what? And yeah, I have to discard. I have to build a hash map basically. Well, just a hash set. And yeah, it should be it. So has visited. Have you done the... At least from Discord here. Oh! Makes sense. Well, actually, I was like, Alfish, Alice, yeah, makes sense. Actually, no, it doesn't. Still on day 10, I see. Yeah, I mean, I just started tonight, the day 10. I mean, basically, like, well, almost 6 hours ago, I guess now. But actually, the first one took me a lot of time because I had some trouble with debugging because it wasn't how I expected the... I didn't take into account something from the... It wasn't like my code was correct, but I didn't have in my head the correct visualization of the thing. If you know the trick, apparently it can be somewhat fast. If you don't use the trick, it can take a good while to figure out. Okay, I'm just going to make a set for now. And it's like breath first, so it's like... It should be pretty good. Yeah, I think it should be pretty good. So it's a set of integrals? No, not integrals. Of a list of shit. Let me think. So if I do that, does that mean I have to make a hash of the list of every number? Maybe I do. As visited. Yeah, because I'm just going to have a reference here. Anyway, just finished day 12, and now I need to get some shopping done, okay? Might pop in a couple hours later to see how things go. Good luck, thanks! Enjoy your shopping, bye-bye. Enjoy. Yeah, I guess my main problem is about the stat. That's kind of funny. But here it is. Here it is. A trick, huh? What would it be? I mean, I think I'm pretty good with my breath first approach. That is checking for... Oh, has visited. Let me think. Actually, breath first. Well, actually, yeah. Actually, I think this is pretty good. I think my approach is pretty good. Well, actually, even if I make a list, is it actually going to do... Actually. Yeah, it is going to do stuff. Okay. I mean, I guess I can... Okay, let's do something a bit risky, shall we? Let's just put an integer. So that way we don't compare the lists, and let's have hash of a list of integers, and it's going to be... Can I just hash... Yes, hash? Yeah, okay, it exists. So I can... I mean, yeah, that's fine. And then hash. Let's say this is 0. I'm going to return that. Then I'm going to do L. Oh, that's actually... I can actually do a... No, I don't care. Actually, I do. I can actually make a rolling hash some kind of ruling hash. Maybe. Can I? I don't know. I don't know. Let's have self, because it's going to depend a bit on that. Self dot targets. I maybe. I. Yeah, for I in range. And this. So we have the targets. What I'm basically going to do is multiply final hash times equal this, and then I add li. I think that's a good hash, because basically we know, maybe with a +1, wait. But yeah, because yeah, because basically we know that we're not going to pass this. And I guess we still want the, no, we do have the minimum amount of combinations, always, because it's breath first. So I guess, wait, if I do death first, that means I can pre-compute a lot of values already. Oh, but wait. Yeah, those values are going to be overwritten, so it is like kind of useless. Yeah, okay. Yeah, it's better this way. So it's like some kind of special hash, right? Well, custom hash. So I have this, and yeah, it should be unique. Well, it is unique, actually. I guess I'm just going to put 0. So, I mean, I'm not even checking this. I shouldn't even be checking this, so this is fine. If should add. So I guess I have the copy, right? Next state. And not has visited. Yeah, let me. Yeah, I don't need the death. Yeah, let's do it here. Has visited becomes true. Oh, wait. Because if I do this, does that mean that last switch index is like the optimization with last switch index is going to not work anymore? Oh no. I mean, I guess it's fine because because we are going to cut this anyways. Yeah, we're going to prevent duplicates anyways this way. So that's like some kind of generalization, I suppose. So let's compute the hash, like state hash, custom hash. And this is the state. Discard intersection. Intersection. Oh, okay. But remove, update. So I guess it's if state hash in has visited, then I continue. If not, then I have has visited dot add state hash. I don't need a hash map. Well, I do have a hash map actually. This is fine. Is it actually a tree or mutable? Alias mutable such. Ah! This is fine. No, this is fine. This is a hash. I know because you can't. Because it's not sorted. But what? Dictionary. Up again. So I think it's not going to work because of what? Ooh, so slow. Yeah, this one is like really slow. Let me check. It's like the third. It's like this one. Ooh, yeah, indeed. Wait, what? What? Oh, okay. I guess it's some linear combination thing. Mm. So am I going to have to use math? Ah. Yeah, because like this one is pretty long. Yeah. I'm like only at the fourth run, right? Yeah, maybe I'm going to have to use this. I mean, yeah. For... Oh, wait. Oh wait, 1, 2, 3, 4, 5. 1, 2, 3, 4, 6, 7. 2, 3, 4, 5. So wait, what is it saying again? Correctly configure, so it has to be equal, right? Okay. Yeah, I guess I actually have to check. Hmm. Like, I feel like I have to do some stuff with the PGCD. Like, basically find multiples. I mean, I'm doing that in debug too, right? Let's just line for I in range. And then I'm going to print front line, I guess I guess it's like the one that is after that, but that's fine. And let's run again, maybe. But this time not in debug. This one is so long. But like everything should already be computed, so I guess it's because I mean I have multiple programs in what I do, even if like there's no trick, right? The problems are that I'm doing copies. And the other problem is that I'm looping every time. Line 3. Oh, I forgot or. Yeah, yeah, I think I'm too tired to find the solution. Should I stop? Counters. And I represent that visually, spatially. First one. Oh, I have an idea. No, I don't. Okay, so I had the DP approach. I can instead have like booleans, like is checking or something like that. Um, I mean, instead of my never mind, never mind. I feel like this is not even going to be right. This is just line 3, my god. Yeah, this is definitely not the way. That's definitely better. I, I mean, with breadth first, I'm just going to do everything one by one, right? So I mean, okay, let's try with something else. Yeah, but I mean, if I do, it's going to become a map. Do I have a try get or something? I don't. Yeah, let's try maybe simple Q becomes a list. Now instead of that, I'm doing a but best first. And at the end, I'm doing a push, an add, an append. And yeah, this is going to become pretty bad. So let's have... But yeah, as I said, it's just going to erase everything, right? Well, not everything, but... Yeah, if it's low as a breath, first would be... okay, let's test. Let's give it a try. I don't think it's going to lead to anything, but we never know. Well, I mean, I think I do know, but... Here we go. Then this is basically V. Deleted NV switches. And if this is less than oh right, wait. Has visited. Yeah, I can have some giant list actually to check that. Wait, actually it doesn't matter. Wait. If it's already visited, then it's already visited. If this is less, then then what's NB switches? Then we continue. Else, I'm going to update, and we continue. Yeah, let's try, but I really don't think this is going to lead to anything. Right? Yeah, not because of that though. Map. Yeah. Okay. I guess this is hash equals NV switches. Oh, so I guess it's just the same thing. Wait, this is so fast, what the fuck? Oh, wait. I think I kind of know. Is it because of that? It probably is. Let me make sure. Yeah, it's actually pretty fast now. What the fuck? Wait, which one is it? Let me actually check if this is correct, because now I have like test input. So total is 40, right? No, it's not. Fucks. So what went wrong? Current line. 1, 2, 3. Never mind. Oh. Results are. Let's just add some tabulation. And let's do it again. 10, 14, 16. 10, so this is good. Then we have 14 and 16, which isn't good. So this one is fine. But this one and this one's are not. Don't tell me that this is a problem about the input again. No, I had a 33 before. Right. So hey, why is it so fast? If next state ID is bigger than okay. For every switch, I increase the amount and I append. And I only stop one. Oh yeah, actually it makes sense why the death first would be faster. We did. Yeah, because for very, very slow. Because that means breath first is doing very slow inputs first. Well, tests first. Anyway, this last switch index is not considered anymore. So what's the problem with this? Fourteen is the minimum. And let's do the current line. Here we go. Maybe it's because of the hash. Maybe it is. What if I modify this? To like something like times 13. it's not changing anything. So yeah, I mean, the logic was right, so it's probably, it's not that. Yeah, let's pop. Let's append 0, 0, 0. So then we go. We have the state, we have this, we compute the hash. If the hash is in what is visited, then we retrieve the value. And if this is less or equal, wait, this is the opposite, right? No, never mind. If this is higher or equal, then I continue. Yeah, okay, this is fine. Then I set and B switches. If this is equal, then I return. Okay. Then for every switch, I get the switch. I copy. If I should add, okay. ID in switch. Next ID false. Yeah, I mean, okay, it makes sense. I break. Yeah, I really don't know. It's not correct. I'll verify my input again. But I don't think that's it, right? I mean, the first one is correct. So let's get this one. Zero, 2, 3, 4. 1, 2, 3, 4. Yeah, this is correct. Yeah, this is correct. This one is supposed to be fine. What if I do not have the has visited? What if I remove this? Is it because of this? This is possible because this is what I did basically, right? 10, 14, 16, 40. So this is not because of that. This is not because of the queue. Interesting. Wait, if it's not because of that, then why? How? Then that means at one point... Oh, if it's equal. Oh yeah, I forgot about this. Oh no. It's just finding the first one. So now I have to go through all the thing. Just to be sure there's no... Well, okay. If it's equal, then mean equal. Oh, I guess that makes sense because then I can just. Oh yeah, okay, death first. Then I can just prevent new searches. Max death, max search death. Let's put something like. I think I had all this, right? I have the maximum there. Compute hash. So I guess it's actually the hash of what? It's actually the hash of the target, right? Max search death, this is it. And if I find, then max search thing is this. I don't have the death. Wait, I do. NV switches. Oh, that's so stupid. What a name. What a name. I should have just called that death. So if this is, then I'm just actually going to compare. If this is less than this, then I'm going to set it. And if this is more, well, yeah, now let's return. And if this is more, I guess it's just to continue actually. Wait, oh, I don't have a bounding thing either. Oh, wait, I do. I have this. Right, good. So what was the thing? Oh yeah, the death. So if NB switches is bigger than the max death, then I continue. Something like that. 33, okay, so now it's correct. Now it's correct, finally. Okay, so let's put some print back into the game, like here. Okay, fast. I like that. Why so many? Oh, right. I forgot. Well, it doesn't work anymore because it doesn't work the same way. Current line 1. What line? Oh yeah, I mean I guess it's not a line, but is it really going to work faster? I mean the breath first was actually faster. Oh no, I made it even slower. Oh no, I made it even worse. Oh no. I mean, yeah, I did say that breath first was better at first, but I guess now I have the limit. It's like what? It's like 150 lines, 60. Yeah, breath first was better. Yeah, okay, this is never going to end. Yeah, breath first was better. A little trick. What can I do? I mean, breath first was good. Well, it was actually possible. It would have been slow, but it would actually have been possible with breath first. I guess. Let me think. Oh, can I? Yeah, can I curl? One. Can I like sort? Uh, because for example, for modulars, I can like divide by 2, right? I guess I can't really do that here. 7. Um, I guess I can try to double things. Oh yeah. Oh yeah, I can try to double things. Instead of having a list. Okay, instead of having a list, I can, yeah, basically do multiplications, right? 1. So it's actually, oh, yeah, I went at it the wrong way. Um, yeah, okay, I understand. Yeah, I went at it totally the wrong way. Yeah, it's basically multiplications. So I basically have to 1, 2, 3. Have to multiply until it's too much. I have to check every unique combination because it's multiplication, addition. Okay, let me just do it to this. Okay, and now it should be good. And now I'm just going to Control V. And this is depth first search. And this is breadth first search. So I still have my optimizations. And yeah, now it's like, yeah, I understand now. Okay, so okay. I um uh, wait, let's say I have 5. Okay, let's have a list that is coefficients. First is going to be like 0, so 0 times everything. Length of self the targets. Yeah, it's going to be a lot better now. No allocations, no, all of this. So for I in range, actually, well, no, let's. I was gonna brute force it even more. I mean, I could for I in range. Well, while coefficient. Oh, actually, I could even prevent multiplying everything. Oh yeah, I can. Oh, I can optimize that like crazily. Yeah, I can totally optimize that. I can totally optimize that. Let's have a while true. A little while true. Let's actually have a current total equal 0, 0. Let's say it's a list. That's, you know, the same. is equal. What was it? This. Assume that is equal. Current total and self dot targets. If it's not, then I'm going to have an I. Well, actually, just I equals 0. I could use a hash for that, right? But I mean, I only need it one time, so that should be good. If I start from 0, it's going to be very long, right? So I mean, yeah, I should have at least one. Yeah, I can optimize this somehow. But no. Okay, let's do it this way first. So yeah, we have the coefficients. Yeah, so ij 0, 1. Okay. Yeah, okay. While coefficients I equal too much. While it's equal to too much. Maybe current, well. Well, basically the maximum, right? And the maximum is basically okay. Let's compute this max per coefficient. Guess it's a list with this as a length. And for each coefficient, let's have self dot switches. Switch in this. Then you have switch, yeah. So for ID, switch. Then we have this I. So this is actually for I in range length of switch. Wait, what? Wait. Per switch? No, that's not it. For each ID, then this becomes the minimum. Oh yeah, yeah. It becomes the minimum between this and yeah, I mean, I guess 0 is some bad initialization. I could have custom hash of self.targets. Then I have this self targets I. This is the maximum per coefficient. Yeah, and it makes like a lot of sense. And if this is the max, I just have to be careful. But yeah, basically, yeah, this is basically it. I'm gonna have to debug a bit, but that's fine. While this is fine, I plus equal 1. And then so I have I. And then, yeah, for the coefficients, I just do plus equal 1. And then I can just compute again. I guess I go back to 0 actually. If this is equal, I mean, yeah, this is not this. No, this is not good. This is not good. This is not what I want. Yeah, this is not working fine. This is not good. This is not good. Yeah, let's compute the hash actually. Target hash equal self that's custom hash of targets. Then we basically have current hash. Self dot, well, current total. Well, I mean, this is just 0, right? But that's fine. It's just the beginning. So we have the target hash. So basically, while this is not this, it should improve things like a little. Not a lot, but a little. Like divide speed by, yeah, reduce latency by 6 or something like that in some cases. While current total. Oh wait, yeah, that's actually something I should. Maybe that's correct. Yeah, I guess this is fine actually. If this is max coefficient. Uh, hmm. I mean, it basically means if this is higher than, that means this is becoming 0. While this is higher than it's becoming 0. Oh. Okay. Okay, good. Okay, well, this is true. I reset to 0 the current one. I do plus plus. Well, I reset. I do I plus plus. And if it is again more than the max, then this is not good. And I continue. So while I is less than, am I really going to? Because if I go to the end, I mean, I guess I would have the minimum with this. What's the minimum? Oh no. What's the minimum? Wait. In that case, what's the minimum? Oh wait. I just realized. Yeah, what's the minimum? I just have to sort by. Oh. Yeah, you have to sort by those that are bigger first. Oh yeah. Yeah, okay, that's a lot better this way. Because it's adding one anyways, so it's better to start with those that add a lot of ones, right? Something like that. Yeah. Okay, let's do this. Let's go back to day 10 here. And it's going to be breath first. Okay, let's actually try again. Test input. Let's ensure that it works fine. It doesn't. No! No! I don't wanna debug it again. Has visited. Yeah, why do I even have that? Oh, never mind. Press 1, so this is the correct one. If this is bigger than the target, then false, okay. The amount of switches... BFS, wait, it's BFS, right? Yeah, it is. Okay, never mind. Okay, I do have my print about the number of switches. I don't have the optimization anymore about... Oh no. What's this? This is so bad. I mean, I guess it's not even used, but it's still so bad. Okay, let me put a breakpoint. I actually forgot what I wanted to say. Oh yeah, I wanted to sort. Um, yeah. So do. Not visited. Okay. Is machine equal? So yeah, this is going to become empty. Oh yeah, if it reaches here, that means this is going to become empty. That means it's just popping without ever having next state ID. What's ID? Oh, yeah. Press equal to 1. ID free. Switch is free. I am free. A. Press equal 1. Okay. Wait, I don't have a... Oh, I have a is equal. I mean, I guess I can just compare hashes, actually. Oh yeah, and I can reduce like the speed, well, the delay by 6. Yeah, actually, this is a good idea. Yeah, let's maybe go back on that. 3, 5, 4, 7. Okay. Stage. Targets. 3, 5, 4, 7. Wait, it's not. Wait, that's... So I don't know. I still have the death check. No, I don't have a death check. Yeah, because... Yeah, that's normal. Stage. Let me switches. Let's switch index. What if I just do this? $33. So this one is working. Okay, this one is working. When I put 0 instead of 33. Yeah, because it's not the same thing as before. Yeah, this doesn't make sense anymore. So anyway, we have this. Okay, we have this. What if I put input is instead? And what if I, instead of when I have this, custom hash, has visited, state hash. Is equal, so okay. Let's just have a target hash equal this. Max search depth. What is... I don't need this, right? I mean, yeah, okay. Yeah, I mean, I can continue, I suppose. Target hash if state hash equal target hash. Then, oh yeah, I just returned. I forgot to uncomment that, I suppose. Oh no, it's death first. No, wrong one. Wait, what? Let's remove death. DFS. So yeah, this one is 0. We have all of this. We have is equal. We have custom hash. I guess for the custom hash, what can I do? I mean, I can optimize it basically. But well. That's fine. That's fine. Let's just have some target hash equal self does custom hash self dot targets. State hash is not targets hash. I guess instead of that, what I can do is, I don't know if like this is fast or not, but I can have this is a list of booleans, and this is going to be false times oh, this is going to be a lot. Yeah, I'm a bit afraid about that. What is oh no. Then yeah, this might be too much. But I mean, if that's the amount of possibilities, then that means I'm going to reach something like that anyways. How many characters is that? 32. Yeah, this is bad. 32. Because that means that, I mean, no, it's less because you have the commas, right? So if I do like something like this. Well, I think it's like target hash, right? If has visited with the state hash, then continue. If not, then we have this state hash equal true. What is it? Wait, return? Wait, what? Oh, it's if it's equal, right? Yeah, if it's equal, then we return. Okay, run. Okay. And oh, right. Has visited. What is this? Is it just input? No, it's input. Wait, it's input. Wait, is it? Wait, what? I actually found a way to optimize it even more. Like, it's so stupid. I've just been forcing it, but it's so fast. Oh no! Oh, the French. Wait, what is it? Custom hash. Wait, why? It's all of this. Okay, let's check some stuff. So this is the length. What is that? This is equal. Wait, this is equal. Oh, if this is equal, then I just return, right? What is target hash? Yeah, this is equal. So I mean, if this is equal, I can just return. Wait, this is kind of stupid. Yeah, looks good. Yeah, looks good. Wait, NV switches. So I am printing. What? Front line. Oh, never mind. It was just the first line. I'm so disappointed. I'm so disappointed. I think it's so slow because I'm taking on the... I don't know. Yeah, why is it so fast, like so suddenly? From time to time? Okay, it's not anymore. What if I do this? Oh yeah, and I wanted to sort, but is it really going to do anything? It's not. Uh, wait, which one? Two. Yeah, let me think. Oh, I have an idea. Yeah, but it might not work. Yeah. Um, oh wait, actually, basically I was just wondering about like whether there are like complements. There probably are. Okay, I think I have an idea, but it sounds like a pain to implement. Because I would have to basically... Hmm, hmm. Ah. Line 3. Um, yeah, wait, why is it so long? Breath first search. It's not supposed to be this long, isn't it? Because if I have... Yeah, let me... Why can't breakpoint, right? Yeah, let me... Something is not right. Because that should take care of itself. Maybe. Maybe not. Oh, wait, for this one, there's actually a problem. Wait, no, never mind. That's not. Should I just multiply by 2? Something, I don't know. I guess I can remove one dimension, basically. And yeah, the third one is not even the longest. So I mean... But it's about possibilities, right? No, never mind. guess this one is actually the biggest, probably. Oh yeah, I did want to... wait. Yeah, but what after I sort it? Um, I guess... I can stop beforehand with like a multiplication or stuff. Maybe. Maybe not. Never mind. Because yeah, there's multiplications and stuff, right? I mean, I guess I can go back to this. Yeah, so while I is less than this coefficients. No, while I is less than max per coefficient. It's not max per coefficient, but yeah. Yeah. Coefficient. Maybe. Oop. Wait, the max. Yeah, I mean, I guess this is fine actually. And it's not coefficients, it's like if, well, oh, never mind. Length, wait. f of coefficients. And this huh. 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 Maybe let's just have some. Yeah. Okay. Let's try some stuff. E plus. Let's have just I here. Let's have I plus equal to 1. And now in the middle, let's just have if this is well, let's just add basically coefficients I I wait. I guess it's like current total. Current total is 0. Let's have index equals 0 for well, I'm just going to current hash. Okay, if this is less than self.targets 0, then I plus plus red total. And I guess wait. This is not what it is. Oh wait, this is completely wrong. This is completely wrong. So I have coefficients equal 0 times len of self dot switches. Now I'm going to have this 0 plus equal to 1, basically, for example. And then I'm going to have for ID in self dot switches 0. No. This then if coefficient 0 is more than self.targets, wait, oh, it's ID. Wait, coefficient. I guess it's about current total. So it's like for each, I have current total plus equal ID. No. Current total ID, if this is plus equal 1. If this is higher, then that means it's becoming 0 again, right? All of this, maybe not. Yeah. All of this is 0 again. And then I check with 1. And then I continue. Then if this is less, then I kind of what? I guess I still have to remove the current total. Ah. Let's have something like that instead. It's going to be easier. It's going to take a bit more performances, but that's fine. Performance. So then we have this 0. Let's have I inside. We have is valid is while it exists. I guess it's true at first. And while this is not valid, well, okay, maybe this is false. While this is not valid, then we have this. Then coefficients become 0. And after that, I'm just going to... Actually, I want to remove from the total, right? I guess I want to put this value true here. And if this is bigger than this becomes false. I break. And now I'm removing everything from current total ID. So, well, from its coefficient. So it's like current total minus, so for ID. I guess if it's not valid, then I do that and I plus equal 1 to go to the next one. ID is, it's not going to become 0, but we are going to remove so it's like coefficients. We have that equals 0. Then we have like coefficients. Yeah, I think that's it. Okay, can I try? Plus equal 1, current. And if this is equal, oh, I guess I have just to, let me think. Oh, I did it wrong, didn't I? Because this is def first. Yeah, okay, this is def first. Def loop. Let's do another one. Again. So it's breath first loop. We have this 0, 0, 0. Wait. Is it even going to work? No, it's not. Yeah, there's no DFS approach for this. That's fine. It's I plus equal 1. Let's not do that. Can I run? Okay. Let's check. So we have stuff. We have I plus. Hey, everything's good. Then this is valid. And it stays valid. Hey. So we continue. And there is like a lot to do, right? So, okay, there's like a lot to do. Can I optimize this? Because this is going to become really long, right? If I just do this. Yeah, maybe I have an idea. For the first part, maybe. Yeah, but it would only like optimize one thing. But I mean, yeah. Minimum. Plus equal 1. Yeah, I mean, let's say this is fine. Let's continue. Oh no. I. Alright. I plus equal 1. Wait, what? Already? 6. No. Wait, what is even the rest? So. No. Isn't it supposed to go back to 0 at the end? Yeah, it is. Let me print some stuff. Or not. Maybe just conditional I equals 5. Okay. So then it's going to become 6. And it's going to be bad, right? What about this? Well, I mean, everything is supposed to be good. This is becoming 0 because, you know, I don't. Wait, what? Wait, what? Let's try again. So this is 5, this is 5. That's not how it's supposed to be, right? Oh. Twenty-four, 27. So wait, this is 5. This is 17. This is 18. But as you can see, you have like some 0 things that are not set. This question is why. So I equals 0. Oh, right, I do have that. Because I guess I is... Well, it can be a lot, right? I guess in this case it's like 3. Wait. Cells dot switches. 1, 3, 4, 5. Yeah, it's this one. 1, 3, 4, 5. 1, 3, 4, 5. And yeah, indeed, it's like 18, right? So I mean, it makes sense. It's good. Yeah, I wasn't actually thinking it would be like that, but I mean, that's fine. Okay, 18. Hey, perfect. And I is 0. Yeah. So back to 0. For everything in here, this is 0. Yeah. Am I actually supposed to remove this? So we have the +1. Now let's say that we have this one. 2, 3, 5. Oh no, it's bigger. Wait, how? Oh, because I didn't... Wait, what? Current total hasn't been removed. Oh no. Oh, because I'm setting it to 0 here instead of here. Okay. Should be better this way. What is I? That is the question. 6. Okay, let's check the rest. Coefficients. Oh. Well, that's a good thing. Well, I mean, it could be, but I don't think it is. False. So 18. What? Wait, why there? Well, I guess it's the maximum. Well, yeah. So 18. No, it's nothing. Okay, okay. I thought there would be something else, but no. One. 2. I mean, yeah, it makes sense. 3, 4, 5. Okay, maybe 8. 9. And anyway, it just continues to grow, right? That makes sense, and that's great. And what's the deal with that? It's never reaching the goal? Oh, that's because it's never... Target current hash is never computed. Got it. Yeah, let's try something like this. But yeah, it seems like it's kind of working, so that's great. maybe it's a bit too slow. Actually, wait, what? Oh, it finished, but there wasn't anything. I guess it's like a while through, and I check everything, and yeah, something like that, right? So I guess I just have to sum the coefficients. Coef sum equals 0 for coefficients in coefficients. Hello, how are you? El Midian. How are you doing? Are you participating in the Advent of God too? I'm fine, and you? I'm good, thanks. Just a bit tired. But current line, wait. Oh, I have the typo again. No. Yeah, okay, this one is like really slow. I'm trying different implementations for this puzzle. But this one is like the worst so far. It's like so bad. It's really bad. And I don't know how to optimize much more. Because I'm like too tired. It's like 6 a.m. I think I just go very soon, but I did want to find. But yeah, I think my sleep schedule is not helping a lot. Um, a that a times that plus b times that plus c times that. What are you working on? It's called the Advent of God, and it's some kind of basically in every December, you have this event that occurs, as you can see, and basically every day until usually until Christmas, you have um, a new puzzle, you can say, that has two different parts, and basically the goal is just to solve this, to solve that. And I've come this far, but I have some trouble solving the part 2 of the day 10. So yeah, that's what I'm doing right now. The current puzzle is basically what? It's some kind of equation solver. Oh, nice. So you're on Advent of God? Yeah, yeah, Advent of God. I try to optimize things like I can with like funny hashes, but that's not enough. Wait, actually, oh, this is a whole loop. Oh, yeah, but only O and well, oh, well, that's fine. Maybe if it was in C++, it would be a bit better, but I mean, not really. Mm, yeah, I mean, this approach is probably the best, but I don't. Maybe it's because of the memory. Because I could see how to optimize this for like one dimension, but not for like everything. That's like, that would be like too much. Yeah, my problem is like I have press one, press one, press one. I need a times or something. I think the real solution really is like to try to find multiples, like combinations, so that every component is equal. That sounds a bit too complicated. Uh, what about? I might have an idea. I might have an idea. Okay, I might have some ideas. So basically, we have a list of targets. Let's say we want 24 here. Then we want to find one of the lists that contains the element at the index 0, so for example this one, and then I multiply as much as I can, and then I try to subtract until I can put other things. I don't know. Yeah, after that I have what? I don't know. Ah, I mean, I guess the goal is to. Okay, you have an idea. I guess the goal is to not lose the compute time trying to reach the max, but to like always be comparing the max with the max. Yeah, that's probably what it should be. Oh wait, I found something. Wait, did I? What if I add everything together? I don't know. Actually, 6, 6, 6. No, 6, 6. 2, 3, 4, 5. Oh, 2, 3, 4, 5. Wait, 2, 3, 4, 5. 2, 3, 4, 5. So yeah, this one is actually reappearing. I just realized. But if I just remove it, then it's not as if it's going to solve all my problems. Because I might need it, actually. At one point. What if instead of trying to add everything, I... Hmm. Hmm. 3, 1, 0. Yeah, they're all used multiple times. So I can't just add like a simple 1 and multiply it so that it reaches like the end. But I mean, if it's like, if 1 is used like 2 times, I guess I can like add max, then remove, add the other one. Yeah, basically what I've been doing with my brute force version. My latest one. Latest. Um, 2, 3. Yeah, I think I have some ideas. Yeah, I do have some ideas. Uh, that means I have to make a new version. Yeah, fine. Find minimum iterations. Opti, let's call it. So ID to switches. Well, okay. ID to, well, index to switch. ID to switches containing. That's a lot. Mm. So basically I want to get for I in range. I have set that, well, let's just call that length. For the length, Um, yeah. Then for all of that, I guess I have an array. For example, this, and this is going to point to, well, for every switch. Oh, for switch in self.switches, then I have switch dots. Oh, right. For ID in switch. Range. Length. Length? Wait. That's not what I want. Yeah, this is targets. And this is fine. And this is for ID in self.switch is I. Then I'm going to add this ID. So it's like ID to switches, I suppose. And it's like ID towards switches that contain the ID. Actually, indices towards switches that contain the ID. So it's like what is it? I guess it's just this ID. That happened I. Because I guess it's an array of arrays. So maybe something like this. I'm afraid it's not going to work, but we can always... Oh yeah, because it's going to be a reference to the same array. I guess I'm just going to append append. I'll just maybe do I equals this. So then I can append, and then I mean that's already a lot, right? Maybe. Okay, so I have a list of the free things. No, I don't. Oh, right. Wait, no, that's not fine. Append an array. Here we go. Okay, I have that. Oh, chat loading. 2, 3, 5, then 1, 2, 3, 4, 5. So 2 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, it is. Hmm. And then I guess the goal is to work doing the opposite. You like multiply and stuff instead. So like I guess I'm going to take the so complicated. I guess I have to take the minimum. Yeah, I don't know. I think I'll be going for now. Yeah, because I'm going in directions that I don't know what I'm doing right now. Much. I mean, I have some ideas, but then I think about it and I realize that no, it's not gonna work. So I just be going, and I'll get some sleep, and we'll see what we'll do. So good night, everyone. Thanks for watching. Bye bye.